I bet you're sick and tired of doing the same repetitive task over and over again. But what if I said that you can automate all of it? Well, that's exactly what you're going to do in this Python automation crash course. You'll learn how to automate files and folders, process text with regular expressions, and automate repetitive tasks, all using real code and real examples. If you're brand new to coding, don't worry. Check out Andre Nigoy's complete Python crash course, which I've linked in the top right-hand corner, as well as the description down below. Once you know the basics of Python, you're going to be learning alongside Travis Cuzick, a data solutions engineer who's built massive data pipelines for Fortune 500 companies, and is now here to show you how to automate the right way. By the end of this crash course, you'll be well on your way to using Python to become an automation wizard, saving time, avoiding mistakes, and getting things done faster. And because you're going through this crash course, we're hooking you up with something special: free access to the Zero to Mastery Discord community. It's usually reserved for ZTM Academy members, but we're letting you in so you can learn alongside hundreds of others, get help, share wins, and even talk to Travis directly. The invite link is in the description. Alright, that's it from me. Let me hand it over to Travis so you can start learning Python automation. Enjoy!
Hello and welcome to the Getting Started section of the course. Now at this point in the course, I'm going to assume that you at least have a beginner level knowledge of Python programming, roughly equivalent to that covered in the optional Python crash course in the previous section. But whether or not you went through that crash course, you'll probably want to take this section before you get on to all that cool automation stuff in the later sections of the course. And that's because this section is where we tackle all that grody installation, setup, and configuration stuff that's necessary if we want to write and execute Python code on our computer, as opposed to in a cloud-based editor like we saw in that Python crash course. Now again, if you took the last section and saw that we were able to execute all the Python scripts we wrote using a cloud-based editor without installing anything on our machines, you may wonder why all this installation stuff is even necessary at all. Well, there's a couple reasons. One is that automating stuff with Python very often means manipulating files, folders, and other objects on a local physical computer. And that's something that's just very difficult to do from a browser-based editor. Also, it's generally a good idea career-wise to become comfortable with a more professional Python development environment like the one we're about to see later in this section. Speaking of which, what exactly are we going to tackle in this section? Well, first up, you'll install Python on your computer, assuming you don't already have it installed. And I'll provide step-by-step instructions for doing that up next. Then, I'll also provide step-by-step instructions for installing PyCharm, which is that professional Python development environment I was telling you about. Now, the good news is, installing both Python and PyCharm on your computer tend to be pretty straightforward processes. So we should be able to get back to the coding stuff before you know it. Now, lastly in this section, we'll do a walkthrough of that PyCharm development environment, which, as you'll see, has quite a few advantages relative to simpler browser-based editors like Replit. All right, so that's more than enough introduction for this very small section. So I'll get out of your way and let you get to installing stuff. Then we'll jump right back into coding once you're done. I'll see you then. Welcome back. So as you saw, if you took the optional Python crash course in the last section, Tools like Replit offer a straightforward and accessible platform to begin your coding journey, especially if you're new to programming. And if not, assuming you have some other background in Python coding, you probably have some experience in some other relatively basic Python code editor. At any rate, editors like this are fantastic for getting your feet wet with Python's basics. However, as we delve deeper into automating stuff with Python, we'll need something more robust and feature-rich. And that's where PyCharm comes in. So PyCharm is a powerful integrated development environment, or IDE for short, designed specifically for Python. It's a desktop application that offers an array of tools and features to streamline coding, debugging, and managing complex projects. This makes it an ideal platform for the kinds of projects we'll tackle for the remainder of this course. Okay, so now that we understand why PyCharm is our IDE of choice, let's get started actually using it. Now, I'm assuming you'll already have it installed, along with Python itself, based on the instructions provided before this video. Now, as our first step, let's simply open PyCharm. Now, if you've just installed it, you should be able to search for it on your computer by the name of the application. So I'll just type py, and right away, we see the PyCharm application as the first option. So I'll go ahead and double-click this to open. And the first thing we see upon opening PyCharm is this welcome screen, which you can think of as kind of like a gateway to all of your Python projects. From this screen, you can create new projects, open existing ones, or access various settings specific to the PyCharm application. Now, the obvious next step here, of course, is to create a new project of our own, which will help us get a feel for PyCharm and some of its most important features. Now, for our first, very simple project in PyCharm, we'll create a Python script to count down the days to the next New Year's Day. Now again, if you went through the Python crash course in the previous section, you'll probably recognize this script from the last video of that section. But that's fine, since our focus here is on PyCharm's functionality and not the details of the Python code itself. So to begin the process of creating this project, I'll simply click, as you might expect, on New Project here. At which point, PyCharm will ask us to specify a project name and location, all as part of the same file path, which is where all your project files will be stored. Now, when you installed PyCharm, most likely a new folder or directory was created on your machine to house those PyCharm projects automatically. And as you can see, that folder is the default location that PyCharm suggests for us to store our projects. And as with most defaults, there's really no reason to override that, so all I'll customize here is the name of our project. And I'll just call it New Year Countdown. Now, right below where we specify the location and name of our project, we see that PyCharm's telling us that a new virtual env environment is going to be created as the Python interpreter for our project. So what the heck does that mean? Well, virtual environments, in the context of PyCharm, are an essential tool for managing project-specific dependencies. They allow you to create isolated Python environments for each of your projects. This means you can have different versions of libraries and even different versions of Python itself for different projects without causing any conflicts. Using virtual environments ensures that your project is self-contained and reproducible, which is really crucial for collaborative work and seamless deployment. Now, all of these things are very good, by the way, so we'll leave this default of new environment using virtual env in place. Now, of course, the fact that this new virtual environment is functioning as our Python interpreter begs the question of what a Python interpreter is. Well, you can think of the interpreter quite simply as what runs your Python code. So because different virtual environments can potentially have different versions of Python, you actually have the option of choosing the base interpreter for your virtual environment. Now, there can potentially be multiple interpreters to choose from for those different versions of the Python language, but it's generally a good idea to go with the most recent one available, so that's what I'll do here. Now, that's pretty much it for the initial configuration of our project, so finally, I'll just go ahead and click Create, after which PyCharm will take a moment to set up your new project environment. So at long last, after waiting for PyCharm to set up our project, which, depending on your machine, might have taken a little while, here we are. And this interface you see here is where all your Python coding, testing, and debugging will take place. And since understanding this environment is key to making the most out of its features, let's quickly step through its core components. Now, on the left, we have the Project Explorer. This is where all the files and folders of your project are displayed. Now, in online editors, you may see a simplified version of this. Here, you can easily navigate through your project structure, create new files, or organize resources. Now, this central area here is the code editor. This is where you'll spend most of your time writing and editing your Python scripts. Compared to basic editors, PyCharm's code editor is much more powerful, highlighting syntax errors, offering code suggestions, and much more, as we'll see. Now finally, at the top of the interface, we have the toolbar, which provides menus that offer quick access to a wide variety of functionality, from running your script to accessing project settings. While browser-based editors like Replit, for example, tend to offer somewhat limited options, PyCharm, as you can see, gives you a wide range of tools and preferences to customize your coding experience. All right, so now that you're familiar with the landscape of PyCharm, it's time to dive into what we're really here for: coding. Let's start by creating a new Python file in our project. We can do this by right-clicking on the project name in the Project Explorer, then hovering over New, and then choosing Python file. And now we just need to specify a name for our file, and I'll call it New Year Countdown, and then hit Enter to create it. So now, with our new file open in the code editor, let's begin writing our script. Now first, we'll need to import the datetime module, which allows us to work with dates and times in Python. So I'll say from datetime import datetime. Next, let's get the current date and time. We'll use the now method from the datetime module to do this. So I'll say now equals date. So as I start to type out datetime, note how the Python code editor anticipates what I'm trying to do. That's PyCharm's autocomplete feature, which is significantly smarter and more robust than similar features in lesser code editors. So all I have to do here is hit my Tab key to lock in that suggestion. And now I've saved myself 4 precious characters of typing, which for a terrible typist like me is a pretty big deal. But what I'm trying to do here actually is call the now method on datetime. So if I type dot here, that same autocomplete feature lists out all the methods that are available on that datetime object. Now, if I needed one of these other methods, I could simply arrow down to select them, but conveniently, the one that I actually need is listed first, so I'll just hit Tab to lock that in. And once again, I've saved myself a decent little bit of typing. So as our next step in this little script, I'll actually define the New Year's Day we're counting down to. So I'll say New Year's Day equals, and here, instead of calling a method on that datetime class, I'll actually use the datetime class itself to define a date. Now note that after I've typed out this datetime class, which we're effectively using as a function here, a tooltip appears directly above it, showing me the expected parameters: year, month, and day, in addition to some optional parameters like hour, minute, second, and so on. These kinds of tooltips ensure that we input parameters to functions correctly and understand what each parameter represents, which is especially beneficial when working with unfamiliar methods or complex libraries. So here I'll just say year equals now.year, but I'll actually want to add 1 to that because I want the next year relative to the current year. And then I'll say month equals 1. But again, note how this autocomplete feature within the PyCharm editor automatically suggests this second parameter of the datetime function / class. So I'll just hit Tab to lock that in, and we know the month is 1 because it's the first month of the year. And finally, day also equals 1 since it's the first day of that month. So as my next step, to find out how many days are left before that day, we'll calculate the difference between that next New Year's Day and the current date. So down below, I'll say difference equals, and then I'll simply subtract the value in our now variable from the value in our New Year's Day variable. Pretty standard, basic date math. So with a little help from autocomplete, I'll just say New Year's Day minus now. But this is interesting. Even though this code is quite basic and I'm fairly confident is syntactically correct, we now have a little squiggly line below the last section of this expression. So what's going on with that? Well, if I hover over that part of the code, we see a message saying that there's missing white space around the operator. And sure enough, it looks like I neglected to put a space before that minus sign. Now that doesn't mean my code is syntactically incorrect. This code would actually still run and execute just fine. But PyCharm doesn't just give you suggestions pertaining to your code's syntactic accuracy, but also its style or formatting. There's a fairly elaborate system of formatting and organizing Python code that the PyCharm editor will gently try to nudge us in the direction of, using the kinds of squiggly lines we see here. Now, you absolutely have the option to not take these suggestions, but in general, you probably should. After all, those standards are there for a reason. So I'll go ahead and put a space in between New Year's Day and our minus sign, and now that squiggly line goes away. But we still have one under now. So if we hover over that, this time it looks like the formatting issue is that we don't have a new line at the end of the file. Clearly, that is also considered to be a formatting best practice. So if I now add a new line to the end of our script, that squiggly line goes away as well. Finally, it appears we've made PyCharm happy. So this automated process whereby PyCharm, or any other editor for that matter, checks our code for potential stylistic issues or errors, which I can assure you will be pointed out as well, is called linting. Linting is basically what highlights problems as you type, which greatly aids in maintaining clean, error-free, and readable code. Now, as the final step in completing our script, let's extract the number of days from this difference and print the results. So down below, I'll say days left equals difference dot days. Then below that, using an F string, I'll print the sentence, there are, and then I'll insert our days left value in this string using the magic of F strings. Days left until the next New Year's Day. So now that we've typed out this line, we see yet another squiggle under another part of our code, this time a green one. So let's hover over that to find out what that's about. And here we see that PyCharm also has a built-in spell checker. It recognized that I mistyped the word days, and it's actually suggesting the alternative. So instead of retyping the word, all I have to do is just click replace with days. Okay, so now that our script is complete, I want to draw your attention to one more handy feature of PyCharm and other professional IDEs like it: syntax highlighting. This feature intuitively differentiates elements of your Python code through color coding, making your code easier to read and understand at a glance. As you can see from our little script here, keywords, variables, strings, and various other elements each have their own distinct color. This not only makes your code more visually appealing, but also helps in quickly identifying syntax errors, understanding code structure, and enhancing overall readability. As you type, PyCharm automatically applies this color scheme, which turns your overall coding experience into a more efficient and error-resistant process. All right, so with that, now let's actually run our script and see PyCharm in action. Now you can just right-click anywhere in the code editor and select Run New Year Countdown, the name of our program, but the easiest way to me is to just use the green play button in the top right corner of our interface. So I'll do that. So after our script executes, we see a new window at the bottom of our screen, the Run window. This is where the output of our script is displayed. And based on this output, which says that there are 356 days left until the next New Year's Day, I believe our script is working just fine. But if there had been any errors in the execution of our script, this very same Run window is where PyCharm would show us exactly where they occurred and provide hints for fixing them. And as you'll see as we work through significantly more complex projects throughout the rest of the course, that feature comes in very handy as well. All right, so that's a wrap for all the setup and configuration type stuff we've tackled in this section, which means we're ready for the fun stuff. That being automating things with Python, of course. I mean, hopefully it hasn't been all that unfun so far, but I can assure you that it's only going to get more interesting from here. And to that, in the next section, we'll tackle our first automation project as we learn to manipulate files with Python. See you there. Hey, welcome back. So to start our journey towards mastery of all things text file related in Python, let's briefly explore the most basic of all text file types, plain text files. So what exactly are these, and why would anyone use a file that literally has the adjective plain as part of its name? Well, to answer the first question, plain text files are basically computer files that contain unformatted, human-readable text. They're the digital equivalent of a plain sheet of paper with nothing but typed words on it. Unlike other files like images, videos, or documents with fancy formatting, plain text files are just plain text with no frills. Now you might be thinking, but why would I want a file without any formatting? Well, sometimes there's beauty in simplicity. The lack of formatting in plain text files makes them incredibly versatile and easy to work with. They can be opened, edited, and saved with any basic text editor on any computer, without the need for special software. So what are plain text files used for? Well, one common scenario where you might encounter plain text files in the wild are as configuration files. Many software applications, especially those that run behind the scenes, use plain text files for storing configuration settings. These files can be easily edited by a user or administrator to change the behavior of the software. Now, if you've ever taken a peek at the inner workings of a computer program, you might have noticed that it's usually written in plain text. Programmers write code in plain text files so that it can be easily read, modified, and shared with others. Now, as another example, have you ever written a quick note to yourself or a shopping list on your computer or phone? Chances are you used a plain text file to do it. They're perfect for jotting down simple notes because they're easy to open, edit, and sync across devices. Now, as a final example, in the world of data analysis and processing, plain text files are often used to store and share data in a simple, easily readable format. This makes it possible for different software applications to communicate and work together. Okay, so now that we have a handle on what plain text files are, it's time to tackle the truly fun stuff: how to automate the process of working with them using Python. We'll tackle that in the next video. See you then. Hey, welcome back. So now that we understand what plain text files are, let's jump right into working with them, specifically reading them using Python. For our example, we'll be using the text file you see here, which simply contains 20 different dad jokes, one on each line. So for example, why don't scientists trust atoms? Because they make up everything. Okay, I guess that's kind of clever. How do you organize a space party? You plan it. I think they should call these bad jokes, not dad jokes, am I right? Wait, I think that in and of itself might have been both a bad joke and a dad joke. Yikes. Okay, let's just move right along with the example now, shall we? So zooming in on the structure of the file, and not the terrible jokes it contains, this format, in which each piece of data is listed on a different line, is quite common among plain text files, but by no means mandatory. Some text files can have all the data on a single giant line, while others are more structured, with delimiters, basically some text character splitting the data into columns. But when it comes to plain text files, again, this format you see here is very common. So now that we've seen the data we'll be working with, it's time to fire up PyCharm and create a new project for this section. So let's go ahead and do that. So first I'll fire up PyCharm, and then I'll hit our trusty New Project button. And then I'll name this project Plain Text Files. So with our project named, I'll uncheck this box down here that will optionally create a main.py file in our project, and then I'll go ahead and click Create. After waiting a few seconds for PyCharm to configure our project, I'll go ahead and create a new Python file by right-clicking in the project window, then hovering over New, then Python file, and I'll call our new file read.py, since the code we'll be writing will read the contents of our text file using Python. And then hitting Enter. There's our new Python file. Now, to make a little more room for our editor window, I'll go ahead and collapse the project window here. Okay, so before we can read our text file with Python, we first need to make sure that that file is located in the same directory as our Python script here. Otherwise, we would need to give Python the full path of the file. That is to say, its exact location on our machine, as opposed to just the file name. Now, there is an art and a science to dealing with file paths. And don't worry, we'll get to all of that in just a bit. But for now, we're just going to focus on files themselves, and not their locations within the tangled web of a computer's file system. So what we'll need to do is simply navigate to whatever folder PyCharm created our new file in, and you can actually see this by hovering over the name of the file in the editor window here, and then paste our target file in there. So let's go ahead and do that. So we can see the exact directory our file is located here. So I'll go ahead and navigate to that, and then I'll drill into that folder containing our project, and then paste our dad jokes text file right into there. And now going back to PyCharm, we're now finally ready to start typing some actual Python. Now, first things first, before we can read this file with Python, we first need to open it with Python. To do that, we'll use Python's built-in open function. So the open function takes two arguments: the name of the file you want to open and the mode you want to open the file in. For our example, we'll use read mode, which is represented by the letter R. So here's what that looks like. First, we'll type that name of the function, open, and then open parentheses, and then the name of our file, which is simply dadjokes.txt with an underscore in between the words. And then the second argument of that function will just be the letter R, again indicating that we want to open the file in read mode. So this function returns a file object, and to be able to work with this file easily, I'll actually assign the return value of the open function to a variable that I'll call file. So right before the function call, I'll just type file equals. So now that we have code in place to open the file, we're ready to read its contents. Now, there are several ways to do this in Python, but we'll focus on two popular methods: read and readlines. First up, the read method reads the entire contents of the file and returns them as a single string. To see what that looks like, let's call the read method on our file variable here and drop the return value of that method into a new variable I'll call content. So on our next line of code here, I'll just type content equals file.read. Then we can finally view the results by simply printing the content variable. So if I go ahead and hit our play button here in PyCharm to run our code, scrolling through our output, we can see that this code in fact reads the entire file in one fell swoop. Our entire list of dad/bad jokes are here, which could be a good or a bad thing depending on your perspective or sense of humor. Now, once you've opened and read the contents of a file, it's important to always close the file. Closing a file releases the resources it's using on your system and ensures that any changes you've made to the file are saved. One way to close a file in Python, now we'll see another, possibly more efficient method in a moment, is the predictably named close method. We simply call this method on the variable containing our file object as follows. So we'll just say file dot close. And then running our code again, everything works like before, except that now our file is safely closed after it's been read and printed. Okay, so that's pretty much the basics on opening, reading, and closing files. But as you know, if you've been programming long, there's just about always more than one way to get something done. And sometimes each different method has its own distinct advantages and disadvantages. So in the next video, we'll look at alternative approaches for both reading text files and closing them. I'll see you then. Hey, welcome back. So while reading the entire contents of a text file into a single string may seem convenient, and for small amounts of data, it sometimes can be the best option, it's often useful to be able to work with a file one line at a time. This can be less taxing on your computer's resources if you're working with a really large file, since you're not holding the entire contents of the file in memory at one time, and it can also allow you to apply more granular logic to the individual chunks of data, that is to say the lines, that make up the file. To see how this works, let's first create a new Python file that we'll call readlines.py. So I'll go back to our project window, right-click, new, Python file, and then readlines. Then to save some typing, something I always advocate, I'll go ahead and copy over this first line of code from our other file that simply opens our dad jokes text file. And I'll also go ahead and collapse this project window again just to make a little bit more room for our editor. But now, for our second line of code here, instead of calling the read method on the file variable like we did before, we'll call the readlines method on that variable, and then assign the result to a variable called lines. So on this next line of code, I'll type lines equals, and then file dot read lines. So unlike the read method, the readlines method reads the file line by line and returns a list of strings, where each string is a line from the file. Now, to view the individual lines of the file, we'll need to iterate through the list in our lines variable, which we can do with a for loop. So I'll go ahead and set up the basic structure of the for loop right here below our second line of code. So I'll say for line in lines, and then in the body of the for loop, I'll simply print each individual line. And now, running our code, now sure enough, we see our jokes listed out just like before. Well, almost just like before. So if you look carefully, you'll notice that there's more space in between each line in our readout than with our last example. So why would that be? Well, it turns out that when you have a text file broken up into multiple lines, each line technically includes a new line character. This is what actually causes the text to be broken out into multiple lines in the first place. But when we print the contents of the text file one line at a time, these new line characters create unnecessary spaces between each line. To get rid of those, we can call Python's strip method on the line variable inside of the body of the for loop. This will remove any leading or trailing white space, like a new line character, for example, from each line. Now when we print each line, we should get just the dad jokes, one per line. So let's try that. So right here on our line variable inside the loop, I'll just call that dot strip method. And then running our code one more time, we still have our jokes, but now we see that those spaces in between the lines are gone. Okay, so before we eagerly tack on that file.close method to the end of our code, let's take a look at an alternative, often more convenient, way to work with files in Python: the with statement. So the with statement works as what's called a context manager. In practical terms, this means it handles opening and closing the file, so you don't need to worry about calling close manually. How this works is we open the file using the with statement, and then any code that operates on the open file will be grouped as an indented block, much like an if statement or a for loop underneath the with statement. So let's see what that code actually looks like. So right here before our very first line, I'll type with, and then I'll actually cut this name of the variable out, because in this structure, that name will go at the end. So we say with, and then our open function as the name of our variable. So the file object will still be assigned to our file variable just like before, and we'll still be able to access that file variable just like before. It's just that with this syntax, the order gets switched around a bit. Now, the other thing to remember here, syntactically speaking, is we need to indent all of these other lines of code underneath the with statement. Basically, any code that needs to run while that file's open will be part of that indented block under the with statement. Then, if we needed our program to do something else that didn't have anything to do with that file, those lines of code would not be indented. And that would tell Python those lines of code have nothing to do with this context manager that we created with the with statement. So I'll go ahead and hit Tab to indent these lines. And now, the cool thing about this structure we just went to some trouble to set up is we don't need to use that boring old close method anymore. The with statement here automatically closes the file after the last line of code in this indented block. So we don't have to remember to always include file.close every time we work with a file. For this reason, it's generally a best practice to open files using with, because it makes sure that your file will be closed once your program executes. Otherwise, if you don't opt to use this context manager, it's possible you'll forget to throw in that .close method at the end of your code, which could cause your files to remain open after you run your program, leading to headaches down the road. So now, running this code one more time, just to make sure I didn't break anything, it still works, and no file.close required. Okay, I think that's more than enough fun with files for one video. But there's a lot more file-y goodness left to cover. Up next, we'll look at the other side of the coin, writing data to files instead of reading data from them. See you then. Welcome back. So whether you're creating log files, reports, or just want to save some data for later, writing and appending data to plaintext files is a common task in Python programming. So in this one, we'll walk through the process of writing a poem, a really, really bad poem, mind you, to a poor, unsuspecting text file that definitely deserves better. Let's get started. So back in our Python project in PyCharm, I'll go ahead and create a new Python file for this video called write.py. So I'll right-click over here in our project window, and then New, Python file, and then I'll just call this write. And then I'll collapse our project window to make a little bit more room for our editor. And now, here in our new file, the first step in writing data to a text file will be to open the file, just the same as when we read data from a text file. So we'll do that with a with statement, like we saw in the last video, to make sure the file is closed automatically when we're done with it. So that code will start with, and then the open function, and then we'll supply the name of our file to that function, and that will be poem.txt. But to actually write data to this file, rather than reading data from it, we'll specify that we want to open the file in write mode by adding W as the second argument to the open function. So I'll go ahead and do that. And then, of course, I'll assign the file object returned by the open function to a variable called file. Now, it's important to note that opening the file in write mode, like we're doing here, will create the specified file if it doesn't exist and overwrite it if it does exist. So if we don't have a file called poem.txt in the same folder as our write.py file here, this code will create that file. But if such a file did exist, this code will overwrite that file. Okay, so now that we have our file object, we can start actually writing data to the file. So we can write the first line of the poem using the write method of the file object. So entering down, now inside the code block of the with statement, I'll type file.write, and here I'll type out the first line of our poem, and that will be roses are red. Bet you didn't see that one coming. And then, since the write method does not automatically append a new line character at the end of the line, I'll do that here at the end of the first line of the poem. Okay, so at this point, we should have a working program, albeit a small one. So I'll go ahead and run our code. And then, taking a peek at the directory our project lives in, there's our poem.txt file. And if we open it, there's the first line of our poem as expected. All right, now let's continue writing out our masterpiece. To get started, I'll just copy and paste this first line under our with statement 3 more times. And then just swap in the text for the next few lines. So the second line of the poem will be, violets are blue. The third will be, sugar is sweet. Oh boy, I don't like where this is going. And finally, and so are you. Woof. Coding aside, I would not recommend sending this to your significant other. They'd probably leave you on the spot if they have any taste in poetry. Nonetheless, let's go ahead and run this code again. And then check our text file one more time. And sure enough, the new lines are there. Now, since we had already written the first line of the poem to this file previously, you might have expected that line to be duplicated when we reran our program. But that's actually not how the write method works, at least by default. As I alluded to before, the default behavior is to overwrite the existing file entirely. But what if we simply want to add to the existing file instead? Well, I'm glad you asked. So if you want to add more data to an existing file without overwriting its contents, you can open the file in what's known as append mode by passing the A parameter to the open function instead of the W parameter. By passing the letter A as the second argument to the open function instead of the letter W. So creating a new file here in our project that I'll call append, I'll once again start off by using a context manager to open our poem.txt file, this time in append mode. So I'll type with open poem.txt, and then for that second argument, we'll use the letter A. And then, of course, as file. So just that little A will allow us to add data to the end of the file without deleting its existing content. So with this in place, let's add another couple of lines to our terrible poem using the write method in append mode. So here on the first line inside the with block, I'll type file.write, and then this line will be, the sun is bright. And then for the next line, we'll go with, on this lovely night. So these two lines of code will append two new lines to our existing poem, followed by new line characters. So if we run this program now, and then check our text file one more time, there are those two new lines, but this time the original ones have not been overwritten. Nice. Now, as an alternative to writing to text files one line at a time with the write method, we can use the write lines method to append multiple lines to the file at once. This method takes an iterable, like a list or a tuple, for example, containing text strings as its argument. To see how this works, let's first create a list containing a couple new lines of our poem. So above our with statement here, I'll create a variable called additional lines, and that variable will contain a list, which in turn will contain a couple new lines of our poem. So I'll start with stars up above, followed by a new line character, and then our second list item will be whisper words of love. Oh boy. Now, with our list in place, we can use the write lines method to append the individual items in that list to our poem.txt file. So on a new line, I'll write file.writeLines, and then the argument will simply be that additional lines variable we just created. So again, this line of code will append each item in our additional lines list to our existing text file. Now keep in mind that if we didn't include that little A argument in our open function, our file would be completely overwritten instead of these new lines being tacked onto the end of the poem, just like when we used the write method. Now before running our code, I'll comment out these two previous lines since we're writing in append mode, and those lines would now be duplicated in our file. And we should only have to read those stinkers once, right? So commenting those out, and then running our file once more. Let's check our text file again. And it looks like our awful poem is complete. Yay, I guess. All right, so that's pretty much it for working with plain text files. They're simple files that are correspondingly quite simple to work with. But up next, we'll begin exploring another type of text file that lends itself to more complex data and an even wider range of applications, the CSV file. See you then. Hey, welcome back. So now we've seen how to use Python to work with one kind of text file. But it turns out that plain text files aren't the only text file in town. There's another, arguably even more widely used flavor of text file that often comes in especially handy for Python programmers, the CSV file. So what the heck is a CSV file? Well, CSV stands for comma-separated values. It's a type of file format that stores data in a simple, structured way. A CSV file is kind of like a table with rows and columns, where each value in a row is separated from the other values by a comma. Think of it like a spreadsheet without all the fancy formatting and features. So here's an example of what a CSV file looks like. As you can see, this file is a modified version of the dad jokes text file we've already worked with. But this time, the data is organized not just into rows, but also columns, in which the columns are defined by commas separating the values in each row. We now have an ID column, a joke column, and a rating column. Now in theory, the ratings for the jokes should have been from 1 to 5, but as you can see, some were simply so rancid they actually qualified for a negative rating. Joke quality aside though, note that in each row of the file, the values in these distinct columns are separated by commas. You can also see that the first row contains headers that describe what each column contains. Then, the rows that follow contain the actual data. Now keep in mind that while CSV files can be opened in a simple text editor like you see here, the same files are often opened and manipulated by spreadsheet programs like Microsoft Excel or Google Sheets, as you can see here. Contrast this tabular structure with data divided into rows and columns with plain text files, which are basically just a continuous stream of text that doesn't follow any particular structure. It's a different sort of text file with its own unique purpose, or purposes, in life. So aside from the things plain text files are often used for, CSV files are also often used for importing and exporting structured tabular data. For example, you can import data from a CSV file into a spreadsheet application, like Excel or Google Sheets, or a database. Conversely, you can also export data from these applications into a CSV file for easy sharing or backup. Along the same lines, when moving data between different systems, a CSV file can act as an intermediary to ensure a smooth transition. Finally, researchers, data analysts, and businesses often use CSV files to analyze data, since they can be easily manipulated and processed by various data analysis tools. Okay, so that's pretty much the scouting report on CSV files. Up next, we'll take our first look at how to actually work with CSV files using Python, starting with reading those files, similar to how we've used Python to read a plain text file a couple videos back. I'll see you then. Welcome back. So now that we have a handle on the whole CSV thing, let's take a look at how to read the contents of CSV files with Python, much like we used Python to read plain text files a few videos back. To do this, we'll make use of Python's built-in CSV module, which is specifically designed for reading files structured as rows and columns, with the values in each row separated by commas, or alternatively, some other delimiter. So as our first step, flipping over to PyCharm, we'll create a new Python file called CSV Reader. Then, in this file, our first order of business will be to import that CSV module. Again, this is a built-in module, so there's no need to install any external packages. To import the module, you simply type the following line at the very beginning of the file. Import CSV. Next up, we of course need an actual CSV file to read. We'll use an expanded CSVified version of our dad jokes text file that we saw previously. So I'll go ahead and copy that from its current location and then paste it into the same directory our Python files for this project are stored in. So flipping over to that directory, I'll just paste that file in and then head back to PyCharm. Now, before we can read the data from this CSV file, we first need to open the file using the open function, just like we did with Plaintext Files. We'll once again use a with statement so our file is closed automatically after our code executes, and of course open the file in read mode. Then we'll assign the resulting file object to a variable called CSV file. So on the next line, I'll type with open dadjokes.csv in read mode as CSV file. So now that we've opened the file, in order to read it, we'll need to create a CSV reader object using the CSV module's reader function. This function takes a file object as its argument and returns a reader object that we can use to iterate over the rows of data in the CSV file. So let's pass our file object to the csv.reader function and then assign the resulting reader object to a variable we'll call CSV reader. So I'll say CSV reader equals CSV dot reader, and then I'll just pass in our file object as the argument to that function. So with that CSV reader object now captured in a variable, we can read data from the CSV file by iterating over the rows using a for loop. Each row returned by the CSV reader will be a list of strings, where each string represents a field, or cell if you prefer to think in spreadsheet terms, in the row. So let's go ahead and set up the shell of that for loop. So I'll say for row in CSV reader. Now this loop will iterate once for each row of data in the file, and we'll have access to those individual rows via the row variable inside the body of the loop. Now let's say, for example, that we want to print each row as we read it. To do that, we can just add a print statement inside the body of the loop that prints the row variable. So let's add that and then run our file to see what happens. And now running our file. As you can see, while the contents of the file are displayed, this doesn't exactly result in an attractive readout. That's because the row variable, for each given iteration of the loop, contains a list containing the values in the corresponding row. And a list of values doesn't exactly make for the most readable output. A better approach, once we have the data from each row captured in our row variable, is to access the individual fields, or cells if you will, of the row using indexing. In our example file, each row will have 3 values: the joke ID, the joke itself, and the joke's rating. And since these values are stored in a list, we can access them using the list indices 0, 1, and 2, respectively. Let's take advantage of this to customize the output of our program so that the data for each row is incorporated into a complete sentence. We can do this by capturing the values we're interested in from each row in variables, and then plugging these variables into a formatted string, or F string for short, which we can then print for each iteration of the loop. Let's see how that works. So let's say our goal output is to print, for each row of the file, the joke itself enclosed in double quotes, then a semicolon, then a sentence along the lines of, "This joke has a rating of," followed by the joke's actual rating. So our first step here will be to capture the joke and the joke's rating into their own respective variables inside the body of the loop. So let's do that. Now the joke text is in the second column of our CSV file, so in the list for each row, that value will be at index 1, since Python uses zero-based indexing. Similarly, the joke rating will be at index 2 of the list corresponding with each row. So here inside the body of our loop, I'll first capture the joke in its own variable. So I'll say joke equals row, and then I'll plug in that index 1. And then I'll capture the rating by saying rating equals row index 2. Now we simply need to plug these variables into an F string to yield our desired output. Now, since we're going to be enclosing our joke inside of double quotes in our output, we'll want to make sure that the F string itself is nested within single quotes. So let's go ahead and crunch that out. So on the next line, I'll type F, and then single quotes, and then a pair of double quotes, since we want our joke text to be inside of double quotes, and then a pair of brackets, and then I'll drop our joke variable inside those brackets. Then, after the closing quote, I'll type that semicolon, and then a space, and then I'll say, "This joke has a rating of," and then another pair of brackets, and then I'll plug in our rating variable, and then a period. And now I'll just make a little bit of room by minimizing our project window, which honestly I should have done before. And then I'll go ahead and wrap our F string inside of a print function. And now if we run this code and scroll across a bit so we can see the end of the formatted strings that we printed, sure enough, this looks like the output we're looking for. For example, zooming in on this line, we see, "What do you call a fake noodle? An impasta. Semicolon, this joke has a rating of -1. So we've managed to turn those lists of data points into complete sentences that are printed to our console. Now scrolling up, if there's one nit I have to pick, it's that our column headers are included in the output, leading to this line right here that really just doesn't make a lot of sense. These column headers are obviously more for clarifying the structure of the data in the file, rather than providing actual interesting data on their own. So how do we solve for this? Well, since CSV files often contain a header row, and we very commonly may want to skip this header row when processing the data, Python has a built-in function which will automatically advance the CSV reader to the next row, the predictably named next function. To use this function to skip the header row in our little program, we just need to call the next function on the line above our for loop, passing in the CSV reader object as an argument. This will skip us past the first row, that is to say the header row, in our file, before the for loop starts to iterate through the remaining rows. So let's go ahead and add that. So again, below the line where we create the CSV reader object, but before our for loop, I'll type next, and then I'll just pass in that CSV reader object. Now if we run our code one more time, and then scroll up, that nonsensical sentence that was populated by the values in our header row is gone. So there we have it, a clean printout of 20 truly awful jokes alongside their correspondingly awful ratings. Ain't technology grand? Okay, we've seen how to read the data from CSV files with Python. But just like with Plaintext files, we can also use Python to write data to CSV files. We'll explore how that works in the next video. I'll see you then. Welcome back. So now that we know how to read data from CSV files, you guessed it, it's time to learn how to write data to them. Let's get right to it. Now you may recall that when we wrote data to plaintext files, using the code that you see here, the data we fed to the write method was essentially just a chunk of text, which makes sense because plaintext files are themselves just really big chunks of text. But as we saw in the last video, CSV files are a bit different. They have structure. Namely, their data is organized into rows and columns. And how we write data to them reflects that. Namely, when we write data to CSV files, we do so in list form. Basically, each list we write to the file becomes a new row of data, with the data points at the different indices of the list corresponding to the different columns of the file. Now, speaking of lists, here I have the example Python file for this video, which I've already created, called csvwriter.py. Now, if you're following along, feel free to pause the video and go ahead and create this file in our project directory. Now, as you can see, this file already contains some sample data in the form of several lists that I've commented out. Now, these lists contain information about 5 household pets, their names, their favorite snacks, and the prodigious amount of money spent on those snacks per month. As an aside, I can neither confirm nor deny that this data is accurate and totally based on my current household situation, but what I can confirm is that owning pets is a lot more expensive than you think. They are cute little guys, though. So instead of looking at these numbers and wondering how I'll ever be able to retire, instead, let's see how we can write this data to a CSV file. We'll start by just writing this first list here to a file called expensivepets.csv. Now, just like with reading CSV files, our first step will be to import the CSV module. Then we'll use the open function inside of a with statement to create that expensive pets CSV file, open it, and drop it into a variable. So I'll say with open expensivepets.csv. And then, of course, since I'm going to be writing data to this file, I'll open this in write mode. And then I'll capture that file object in a variable that I'll call file. Our next step, much like when we created a CSV reader object in the last video, will be to create a CSV writer object. It works pretty much the same way. So I'll say CSV writer equals, and here I'll use the CSV module's writer function to create that CSV writer object. So I'll say CSV.writer, and then I'll just pass in our file object. Now we can use this CSV writer object to write lists of data to our CSV file. Now, the first thing we're going to need to write to this file is not actually the first list of data, but rather a list of headers. That will make sure that our CSV file has column headers. Now, column headers are not mandatory in a CSV file, but they're generally a best practice to have because they make it clear what data is in what column. So to write a list containing column headers as a row to our CSV file, I'll employ the writeRow method on the CSV writer object. So I'll say CSV writer dot write row, and then I'll pass the list of column headers that I want to be the first row of our CSV file into this function. So first I'll create the list, and then inside of this list, I'll just type out the 4 column headers for the 4 columns of data in our file. So first I'll say name, and then species, and then favorite snack, and finally, monthly cost. Now, below this line, I'll actually write our first row of data. And that will work exactly the same as writing the column headers. As far as the CSV file or the write row function are concerned, a list is a list is a list. It views these 4 values in this list containing our header names just the same as any other 4 data points in any other list that we write to the file. So now let's say CSV writer dot write row, and now I'll just copy in this first list of data. And at this point, we should be good to test our code. So I'll go ahead and run it, and then check our project directory. Sure enough, here's a CSV file called expensive pets, so I'll open that. And there's our column headers in our first row of data, but something is a little odd here. Namely, we have a blank row in between our header row and our first row of data. So it turns out that when writing data to a CSV file with csv.writer, especially on Windows systems, you'll sometimes see these blank rows in between the rows of output data. Now, the way to avoid this is to include an extra argument to the open function that opens the file before you write to it. And that argument will actually be a keyword argument called newline. So we'll add that argument, and then we'll set it equal to an empty string. So now, if we rerun our code, and then check our file once again, woohoo! The blank row is gone. Okay, so now to write these remaining rows of data to the file, instead of writing them one at a time, we'll use the csv.writer object's write rows function as opposed to write row. The write rows function allows you to write multiple rows of data to a CSV file at one time by nesting the lists you're writing to the file inside of another list. A list of lists, basically. So first, let's set up that write rows function. So below where we wrote our last row of data, I'll say CSV writer dot write rows, and then for the argument to this function, I'll first set up the outer list that all of the other lists of data will be contained within. And now all I have to do is just copy and paste these lists of data inside of that list. So I'll copy Julius here, paste him, comma, and then rinse and repeat for our other 3 remaining lists of data. So now that our nested list of lists is complete, I'll run our code once again, then test the file. And it looks like it worked. Both the column headers we specified and all 5 rows of data have been transformed from simple lists in Python to this spreadsheet format we see here. Now, just to clarify, I want to point out that we're not seeing any duplicate data in this file, even though we ran our code that wrote the headers and this first row of data multiple times, because we opened the file in write mode. As we covered previously, opening the file in write mode will overwrite the file if it already exists. So you're essentially starting from scratch every time. Now, if we had opened the file in append mode instead, every time we reran this code, the same rows of data would be tacked on to the end of the existing file. Okay, so that's pretty much it for our survey of methods for reading and writing text files with Python. But to get us warmed up for the project at the end of this section, I want to walk you through a slightly more complex example. So in the next video, we'll write a program that reads data from one file, transforms it, then writes it to another file. See you there. Welcome back. So to help us get ready for our project for this section, we're almost there. I want to walk through a more sophisticated example than we've seen so far. This is going to involve reading data from a CSV file, transforming/adding to it, and then writing the results to another CSV file. Not dissimilar to, but not identical to either, our upcoming project assignment. Let's jump right in. So more specifically, our goal will be to read this now familiar dadjokes.csv data with Python, but then use our Python programming skills to add a new field to the data. We'll then write the results of all that to a brand new CSV file. Now the new field will be called rating category, and it will be based on the joke's existing rating, which you see here. How the logic will work is, if a joke is rated -1 or better, it's merely bad. If the rating is -3 or -2, the joke is awful. And then if the rating is less than -3, it will be classified as abysmal. Now I've already created a starter file for our mini project here. So if you're following along, go ahead and fetch this Python file from the course resources and drop it in our project directory so we're kicking things off in the same place. So here in the starter file, I've already defined a function to encapsulate the rating category logic I just talked about. This function takes in a rating argument, passes it through some if, elif, else logic, and then spits out the resulting rating category. Nothing really revolutionary going on here. Now note that I did have to convert the rating, which looks like a number but is technically stored in the CSV file as a string, to an int on the first line of the function body. Also note that I've gone ahead and imported our CSV module on the first line of the Python file. So with that setup out of the way, let me walk you through the overall strategy we'll employ to get this done. Now first, we're going to open the existing dadjokes CSV file with a CSV reader. Then we'll iterate through all the rows of that file. And then for each row, which will actually be a list, we'll append the joke's rating category with the help of our function we see here. Then we'll append that modified row/list to another list that will hold all of the modified rows. This list of lists is ultimately what we'll be writing to that new CSV file. Okay, so that's a 20,000-foot view of our approach to solving this, but now it's time to get down and dirty with some code. So as a first step, I'll create a list that will ultimately hold all of the modified rows from our CSV file that we'll be creating as we loop over those rows with our Python code. So down below our rating category function here, I'll type modified dadjokes, and then I'll just set that to an empty list. Next up, I'll open the existing dadjokes.csv file in read mode. And then capture the resulting file object in a variable called CSV file. Next, inside the block of this with statement, I'll go ahead and create a CSV reader object. And then I'll use that next function we saw earlier to skip the header row of the file. But not quite so fast on just ignoring those headers from the existing file, because we actually need to write them to the new file. The problem is, we don't want to apply the same logic to them as the actual rows of data, since there obviously isn't a rating value among the headers. So how can we capture those header values without including them in the loop that we're going to use to actually transform the data in the existing file? So fortunately, the next function here actually returns a value in addition to skipping past the next row in the file that we're reading. And that value is just a list containing the values from that row. So here, we can actually capture the values in that header row by simply setting a variable equal to the return value of the next function. Now, while we don't want to apply the rating category logic to the headers we've captured here, we do, however, need to append a new value to the list of headers for the new column that we'll be adding. So to do that, on the next line here, I'll just append a new value to this headers list we just created, with that new value just being the name of the new column that we'll be adding to our new CSV file. So I'll say headers.append, and then the name of our column will just be rating category. Okay, so at this point, we're finally ready to loop through all the rows of data in our existing dadjokes.csv file. So I'll start by setting that loop up. So I'll say for row in CSV reader. And as a first step, I'm just going to test this out by capturing the rating value for a given row, which, if we look back at our CSV file, is in the third column, so that means it'll be at index 2. So here I'll say row at index 2, and then to convert that rating to a rating category, I'll drop this value here into our rating category function that we defined up top. So I'll say rating category, and then I'll just drop this into that function as its one argument. Now, finally, I'll wrap all of this inside of a print function, and then run our code to test it out. And we have an error. And as we should, whenever we see an error, we should calmly read the error text and then see what the heck we did wrong in our code. So here it says, next expected at least one argument got 0, and right away I realize I forgot to supply the CSV reader object to our next function. So let me go ahead and plug that in, and then rerun our code. And now just rolling up our console, it looks like our rating categories are printing like we would expect. So far, so good. So now that we know our logic is working like we want, instead of printing this value we see here, let's go ahead and append it to the row we're getting in each iteration of our loop from the CSV file. So we'll say row.append, and now to the list containing the existing values from our dadjokes.csv file, we're just going to append these rating categories we see down on the console. So now that we've got our modified row, we'll simply append that to our modified dadjokes list that we'll ultimately be writing to our new CSV file. So I'll say modified dadjokes, dot append row. Now, as the final phase of our mini project here, we'll use a CSV writer object to write that list of lists captured in the modified dad jokes file as rows to a new CSV file. So first up, I'll open the new file in write mode. So I'll say with open, and then modified dadjokes.csv. And of course, we'll open that in write mode. And to avoid those pesky blank rows in between each row of the file, I'll also set the new line keyword argument equal to an empty string. And then I'll capture the resulting file object in a variable called new CSV file. Next, of course, I'll create a new CSV writer object. Then finally, and this is the easy part, I'll simply write the lists of data inside that modified dad jokes list of lists to our new CSV file. So I'll say CSV writer dot write rows, and then I'll simply pass in our modified dad jokes list of lists. Okay, so at this point, we should be good to test this code out. So I'll go ahead and run it. Looks like it ran successfully, but the real test will be if we see a modified dadjokes.csv file with a rating category column that actually makes sense given the joke's existing ratings. So let's go check that out. And there's our modified dad jokes file in our project directory. So then opening that up, things look promising, but we are missing one crucial element, and that is the headers for our CSV file. The rating category piece appears to have worked fine. For example, our joke here with a -5 rating has a rating category of abysmal, while another joke with a rating of 1 has a rating category of merely bad. So let's close this file, go back to our code, and see what went wrong with those headers. So rolling back up in our code, there we see the problem. We appended the new value of rating category to our headers list, but we never appended that headers list to our list of lists modified dad jokes. So I'll go ahead and append that right now. So I'll say modified dad jokes dot append headers. So now running our code one more time, and then checking our file again, and then expanding our columns. This time it looks like everything worked out great. Awesome. All right, so that was quite a bit to chew on for one video, but the good news is you're now well prepared to tackle that project that we've been gearing up for. We'll officially kick that off in the next video. See you then. Hey, welcome back. So it's finally here. Your first chance to apply your new skills in manipulating files with Python on your own. So just to recap, we've been building up those skills throughout this entire section to help us complete a project assignment from Bruno, the intrepid manager from Keiko Corporation. The idea behind this project is as follows. Each day, Keiko Corp's Enterprise Resource Planning System, or ERP for short, spits out a plain text file containing a list of all the product IDs for electronics products that were sold the previous day. There are 10 unique products in total, meaning, of course, 10 unique product IDs. But as you can see, the text file has one row, or entry, for each individual sales transaction. meaning that any given product ID is likely to be repeated many times. Now, on its own, this file does not provide a lot of useful information. So what Bruno wants us to do is convert that list of product IDs into a useful report in a CSV file by generating additional columns of data that add meaning and context to that plain old list of product IDs. As you can see in this file, which if you haven't guessed is the goal output of the project, in addition to the product IDs themselves, we have a sale ID column, which is a sequential identifier indicating the order in which the transactions occurred, a column containing the date on which the file was generated, a column containing the product IDs, of course, another column containing the product names, and finally a column with the unit price of each given product. Seems a bit more useful than a big stack of product IDs, right? So that's the what. But what about the how? I mean, other than the fact that you'll be solving this with your Python coding skills, that is. I suppose you could try doing this manually, but why? So as to that how question, I'm largely leaving that for you to figure out. After all, working through these types of projects is how you'll develop the skills to climb the ladder at Keiko Corp, or any other business out there for that matter. With that said though, here's some suggestions, along with some crucial background information to help you get started. Now first up, you're obviously going to need to open and read the plain text file we saw a moment ago. Then you'll want to iterate through the lines of text in that file and generate the additional data points you see here for each one of those product IDs. Then, finally, you'll write the results of that process to a new CSV file. Now that phrase, generate additional data points, is admittedly doing a lot of work here. That really is the key to the whole deal. To do this, you're of course going to need to know the name and unit price associated with all those product IDs that could possibly appear in the plain text file. So I'm going to provide you with a mapping of those in a requirements document in the course resources that you can incorporate into your code. Now there's a few ways you could go about incorporating that mapping, but my personal suggestion would be to use a dictionary. And no, I don't mean to look up how to do it in a dictionary. Now, to generate the current date values in the first column here, on the other hand, you'll need to make use of Python's built-in datetime module, which we covered briefly at the end of the optional Python crash course in the previous section. Specifically, you'll want to grab the date class from the datetime module and then call the today method, which returns the current local date on that class. Now, if you're feeling bold, and I hope that you are, I encourage you to try your hand at tackling this project from scratch, based on just the information I've given you here, which again is also included in a requirements document you can find in the course resources. However, if you'd like a little more guidance, there's also a starter Python file, in which I've used comments to lay out the process of building the program step by step. Think of this like a structured to-do list to help guide you along as you code up your solution. Now, of course, if you're just not comfortable letting go of the handlebars just yet, you can always simply watch my solution video, coming up after this one, and follow along. Even if you choose this path, though, I recommend that you work from the starter file you see here and pause the video after every completed to-do, so you can try to give the next one a shot on your own. Then if you get stuck, just keep watching. But regardless of which path you take through the project, you may still want to watch my solution video just so you can make fun of me for how much better your code looks than mine. I hope and assume that it will. Okay, so with that, I'll get out of your way and let you get to it. Have fun, and I'll see you in the solution video up next. All right, it's solution time. So let's jump right into the project. Now, first up, here in the solution file, I want to point out that I've already imported the CSV and datetime modules, which we will be needing as part of our overall solution. And I've also already set up the mapping between product IDs and their corresponding names and prices. Note that I set this up as a dictionary in which the keys are the product IDs and the values are lists, with the first value in the list being the product name and the second value in each list being the price. Now, you could have just as easily structured this as a set of nested dictionaries, in which the keys were still the product IDs, but then the values were themselves dictionaries. Either approach is perfectly valid. I figured I'd go ahead and knock this out of the way because you definitely don't want to watch me trying to type this entire mess, at least if you have anything to do for the rest of the day. Okay, so with these housekeeping items out of the way, we can get down to the nitty-gritty of our code. So as my first step, I'll open and read the text file that contains our product transactions, basically that long list of product IDs where each product ID represents a sale of that product. So down below the dictionary, I'll type with open, and then my file is productsales.txt, and then I'll of course open that in read mode, and then I'll drop the resulting file object into a variable I'll call file. Next up, I'll read those lines of the file, basically the product IDs, into a list with the file object's Readlines method. So I'll say product IDs, which is the variable I'm going to use to store that list, equals file.readlines. So with all of those IDs captured in a list, I can now loop over that list so we can transform those individual product IDs into something a little more useful. So entering down a couple times, I'll say for product ID in product IDs, but now to actually do something useful with those product IDs inside the body of this loop, we're going to have to do a little bit of setup work. So one of the fields we want to add to our output CSV file is a kind of sequential identifier ranging from the number 1 to the total number of product IDs in the file that indicates the order in which those sales transactions occurred. So to do that, I'm actually going to declare a counter variable outside of my for loop, which I'll call sale ID, and then I'll set that equal to 1. Then inside the body of the for loop, I'll later increment that sale ID for each iteration of the loop so that the sale ID associated with each product ID accurately captures that product ID's order in the original file. Now, for you Python purists out there, yes, I know I could have used enumerate to accomplish this with a bit less code, but I'm trying to keep things simple for folks who aren't advanced level Pythonistas and just want to learn to automate tasks with Python. Now, similarly, my next step is going to be to fetch today's date, basically the current date, into its own variable, again outside the loop, so we can assign that date to all the rows of data we'll be creating inside the loop. We can do this outside the loop since that date's not going to change for any given product ID and won't need to be recalculated for every iteration through the loop. And as I mentioned in the project intro in the last video, we can do that with the today method on the date class in the datetime module. I know that's a mouthful. So right here below our sale ID variable, I'll declare another variable called current date, and then I'll set that equal to datetime dot date dot today. So now, moving back inside of our for loop, my first step here will be to capture the individual product IDs into their own variable. But to make sure we don't have any issues with new line characters or other types of white space messing up our output, I'm going to apply the strip method to those product IDs to make sure that all we have stored in that variable is just the product ID. So I'll say product ID equals product ID dot strip. Now my next two steps are pretty similar to this. We're going to capture two more data points about those product IDs, that being the product name and the product price, into their own variables. But this time we're going to fetch those values from this product data dictionary I've defined up top. So for example, to fetch the product name, I'll take the product ID that we have access to in any given iteration of the loop and look that up as a key in this product data dictionary. And then if I want the name, I'll simply grab the first value in the associated list at index 0. And if I want the price, I'll grab the second value in the associated list at index 1. So rolling back down, I'll say product name equals product data, and then my key will just be that product ID. And then inside the list that lives at that key in the dictionary, I'll grab the value at the first index, index 0. And then price is going to work exactly the same, except we're going to grab the value at index 1. So I'll just say product price, and then index 1. So now we have the sale ID, the current date, the product ID, the product name, and the product price all captured in their own respective variables. So the next logical step is to put all of these values inside of a list, which we'll ultimately be able to write as an entire row to our output CSV file. So I'll enter down a couple lines and then say row equals, and then I'll say current date, sale ID, product ID, product name, and product price. Now again, for all you Python purists out there, I know if we'd wanted to save a couple lines of code, we could have just concatenated the list straight from the dictionary. But again, for now, I just want our code to be as explicit as possible. Okay, so now that we've got all of these values captured in a list that should be mappable, I think that's a word, to a CSV file, now we'll want to set up another list outside of our loop to effectively hold a list of lists. Basically, all these little lists we're generating for each transaction inside the body of our loop. This list of lists is ultimately what we're going to be writing to our output CSV file. So I'll roll all the way up underneath our dictionary, and I'll say CSV data just equals an empty list. And now rolling back down to our loop, I can append our row list here to that list of lists we just defined up top. So I'll say CSV data dot append row. Now finally, before we leave our for loop here, I can't forget to increment that sale ID variable, or else we're just going to end up with a bunch of ones in the sale ID column. So I'll just say sale ID plus equals 1. Okay, so after this loop finishes running, we should have a list of lists that contains all the data we need to write to that output CSV file. So without further ado, let's go ahead and write some code to write to that new CSV file. So entering down a couple times, I'll say with open, and then I'll name our new file productsales.csv. And of course, I'll open this in write mode, and I'll set that new line argument equal to an empty string. And finally, as usual, I'll deposit the return value of the open function into a variable, and I'll call that CSV file. Then inside the block of our with statement, I'll create a CSV writer object using the writer method of the CSV module. So I'll say CSV writer equals CSV dot writer. And then I'll pass in our CSV file object to that. So now that we have our writer object, we're ready to start writing data to our output file. But before we eagerly write our list of lists to that file, remember, we need headers to be able to make sense of the data. So my first step will be to write a single row containing headers for our file to our output CSV file. So I'll say CSV writer dot write row, and here I'll just specify a list of strings that will be the column headers in our output file. So I'll say current date, sale ID, product ID, product name, and product price. So having done this, now we're ready to write that list of lists containing our actual data to our output file. So I'll say CSV writer dot write rows, and then I'll simply pass in our list of lists, which we stored in CSV data. Now at this point, our code should be ready to test. So let's go ahead and run it. So far, so good. So before we actually test the output, let's first review our input file, which is our plain text product sales file that just has this list of IDs. So this was our starting point. Nothing to get too excited about here. But here in this directory, we also see a product sales CSV file. So if I open that, and then expand these columns a bit, look at that. An actual, arguably somewhat useful report generated from a simple list of product IDs. Not half bad for around 40 lines of code, right? All right. So just like that, we are done with this section. But we're not done playing with files by any means. It turns out that there's still a little gap in our Pythonic file manipulation skills. And that is the ability to work with files and the folders that contain them anywhere on our computer, not just the comfy confines of the folder our Python file happens to be sitting in. We'll learn all about that and how to apply that knowledge to another project from our friend Bruno coming up in the next section. See you there. Hey there, and welcome back. So in this section of the course, we're going to be learning all about a powerful tool called regular expressions, or just regex for short. So regular expressions are kind of like the Swiss Army knife of text processing. They're incredibly powerful and can be incredibly intricate, but they can also be a bit intimidating when you're first learning to use them. Now, before we dive in, let's make sure we're on the same page about what we'll be covering in this video. Our focus in this one will be on understanding what regular expressions are conceptually and identifying the types of problems they can help solve. We won't be delving into any Python code examples just yet. Those will come later in this section when we'll explore how to put these concepts into practice using Python. But trust me, the wait will be worth it. Okay, so getting down to brass tacks, what exactly are these regular expression thingies? Well, at a high level, regular expressions are a way to describe patterns in text. More specifically, they're a sequence of characters that form a search pattern. This pattern can then be used to match, locate, and manage text. Now, the term regular expression might sound quite formal and a bit abstract, but don't let that intimidate you. You've probably used a simple form of regular expressions without even realizing it. Ever use a wildcard search while looking for a file on your computer? If you have, then you've used a form of regular expressions. That asterisk you used to denote anything is called a wildcard and represents a very basic form of a regular expression. Regular expressions, however, can take this principle to a whole nother level. They're not just about finding any file or any word. They're about finding specific patterns within text. And we can use them to check if a string of text fits a particular pattern. For example, if we wanted to find an email address within a block of text, or validate if a user's input meets certain criteria, we can use regular expressions to define what we're looking for. And equally cool, regular expressions are language agnostic. That means, once you learn regular expressions, you can use them in many programming languages, not just Python. You see, they work similarly across most different languages with only minor differences, and that's another thing that makes them an especially powerful tool in your programming toolkit. So now, let's take a closer look at the makeup of a regular expression. So regular expressions are made up of two types of characters: literals and meta-characters. Literals are just what they sound like. Literal characters that just match themselves exactly. So if your regular expression is simply the word cat, then that expression would match cat in the phrase, I have a cat. The characters C, A, and T in our regular expression are all just literals. Meta-characters, on the other hand, are characters that have special meaning. They don't represent themselves, but function as a stand-in for something else. Now, some of the most common meta-characters you'll see in regular expressions are the period or dot, the asterisk, the plus sign, the question mark, and the dollar sign, among many others. These meta-characters can denote a whole range of different things, like the start or end of a string, repetition, or even, in some cases, literally anything. For example, the period or dot meta-character matches any single character except for a new line, while the asterisk meta-character denotes 0 or more occurrences of the preceding element. In the end, it's the combination of these literals and meta-characters that allow us to create powerful search patterns and allow regular expressions to be so incredibly useful. But, you might ask, how do these sequences of literals and meta-characters actually work? It may sound complicated, but the core principle is fairly simple. When you apply a regular expression to a piece of text, what you're doing is asking the question, where in this text can I find a string that matches this pattern that I specified? Consider our earlier example of the literal regular expression cat. If you applied this to a longer piece of text, let's say the phrase, the cat sat on the mat, the regular expression engine, which is part of the programming language that handles regular expressions, would start at the beginning and try to find a match. So it would start at the letter T, the first letter in the first word of our sentence, and ask, is this C? The answer, of course, is no. So it would then move on to H, and then E, and then the space, none of which are C. But when it reaches the fourth character of the string, C, it's found the beginning of a match. So it continues to the next character, A, which matches the next character in our regular expression. Finally, it sees T, which also matches. So it's found a complete match, cat. Now, if the engine were to continue, as it would if we were using a global search, which tries to find all matches in the text, not just the first one, it would find that there are no more cats in our string. And so the result of applying our cat regular expression to the cat sat on the mat would be that one match, cat. And with that, I think I've hit my rhyming quota for the day. I'm feeling like Dr. Seuss over here. Anyway, as I mentioned, that's a fairly simple example. Once we start adding meta characters and other elements to our regular expressions, we can create far more complex search patterns. But we'll get into that, as well as some of the specific syntax of Python's regular expression module in our upcoming videos. Now, you might be wondering at this point, why should you care about regular expressions? Sure, they may sound interesting, assuming you're a techie like me, of course, but what's the real benefit of learning to use them? Well, the magic of regular expressions comes into play when you're dealing with highly complex search patterns that would be difficult to describe with conventional string methods in a programming language like Python. Given this, one of the most common uses of regular expressions is in data validation. For instance, expanding on an example I alluded to earlier, consider trying to validate an email address format without a regular expression. This would require numerous logical checks. Are there characters before and after the @ symbol? Is there a period after the @ symbol, but not at the very end? But with a regular expression, you can check for all of these conditions at once. Now, another big application of regular expressions is in data extraction. Say you're given a large text file and you need to pull out specific pieces of information. For example, imagine trying to find every phone number in a document or every email address. With regular expressions, you can write a short piece of code that will quickly locate every match. Search and replace operations can also be vastly improved with regular expressions. Imagine you need to replace every occurrence of a date in a certain format in a large document with a date in a different format. With regular expressions, you could do this in one fell swoop. Now, of course, it's also worth remembering that while regular expressions are very powerful, they're also not always the best tool for the job. For some tasks, simpler string methods may be more efficient and easier to understand. So as with so many things in programming, true mastery of regular expressions means knowing when to use them and when to opt for something simpler. Okay, so with that, we've laid the groundwork for understanding regular expressions and their many, many applications. And while we haven't touched any code yet, I assure you, we're just about ready to dive in. In the next one, we'll start creating and working with our own regular expressions in Python. See you there. Welcome back. So in the last video, we just barely dipped our toes into the world of regular expressions, their power, their components, and why they're such a critical tool for wrangling data in Python. But now, we're ready to jump right in and start using them by writing and interpreting our first basic regular expressions in Python. Don't worry though, we'll start slow and simple, building our understanding step by step. And to make things even more straightforward, we'll be using something called Pythex, an extremely user-friendly online Python regular expression editor. This means no additional tools will be required for you to follow along, at least for now. So head on over to pythex.org, the URL you see here, and let's dive right in. So here we are in the Pythex regular expression editor. You can see two main boxes here. One for entering our regular expressions, and the other for our test strings. Once we've entered both of these, Pythex will then match our regular expression against our test string and display the matches down here in the match result box at the bottom of the screen. In particular, any portions of our test string that are matched by our regular expression will be highlighted in green, as you'll see in a moment. Okay. Now that we have the lay of the land here, let's kick things off by seeing how plain strings work in regular expressions. No tricks, No meta characters, just good old-fashioned strings. So imagine you have a document full of the word banana. And for some reason, your task is to find every single occurrence of the word banana in this document. Maybe you're a banana enthusiast, who knows? So let's say our text string is banana, banana, banana. No matter how you spell it, a banana is a banana. Now, a plain string in a regular expression is as simple as it gets. It matches exactly and only the string you put in. So if we're looking for banana in our text string, we'll just type banana into the regular expression box, like so. And now if you look down at the match result box at the bottom of the screen, you'll see that Python found all occurrences of the word banana in our text and highlighted them in green. But wait, banana with a capital B and banana in all caps were missed. And that's because, as you might have guessed, regular expressions are case sensitive. So let's demonstrate this by changing our regular expression to banana with a capital B. Now, Python found banana with a capital B, but missed all lowercase banana and all uppercase, angrily shouting banana. So the big takeaway from plain strings in regular expressions is this: what you type is what you get. No more, no less. Remember, regular expressions are like that very literal-minded friend we all have. You ask them to grab a banana, all lowercase, they'll get you a banana, all lowercase. Not a banana with a capital B or a banana in all caps. So keep in mind that with regular expressions, as with all other aspects of programming, to be clear and explicit in what you're asking Python to do. All right, so having covered the absolute basics with plain strings, let's move on to something just a bit more exciting. You see, as we barely scratched the surface of in the last video, the real power of regular expressions lies in their meta characters, also known as special characters. And the first one, of many, that we'll look at is the dot, or period special character. So the dot is basically a wildcard. It will match any single character except for a new line. Now to illustrate this, I'll go ahead and paste in a brand new text string. And as you can see, our new test string is, I saw a cat, a rat, and a bat. They were all wearing hats, for some reason. So let's say we're interested in matching any three-letter words in our text string that end in the letters AT. Now, we could write three separate regular expressions. One for cat, one for rat, and one for bat. But with the dot character, we can do it all in one go. So if we type .at into our regular expression box, voila, cat, rat, and bat are all highlighted just that easy. It's almost like magic, right? But one thing to keep in mind is that the dot character is, in regular expression terms, greedy, meaning that it'll match just about any character wherever it finds it in our target string. For instance, even though our intention was to identify any three-letter words that ended in AT, our regular expression also found HAT in the word hats, which is obviously a four-letter word. So in that case, our regular expression found a match in a three-letter chunk of a four-letter word as opposed to an entire three-letter word. And that illustrates both the beauty and the danger of the dot character in regular expressions. It's powerful, but perhaps not always as precise as we might want. Now, of course, we'll see all sorts of ways to apply much more nuance to our regular expressions a bit later on. Okay, so now you might be thinking, what if I actually want to search for a dot itself? For example, what if I want to find sentences in our string that, of course, end with a period? Now, if you recall, we said that a dot is a special character that stands in for any other character. So if we just type a dot in the regular expression field, as you can see, every single character in our test string now matches. And that's obviously not really what we want. So in this particular case, we need to tell our regular expression that we're looking for a literal dot, not the wildcard dot. And we can do this by using a backslash to quote-unquote escape the dot. In regular expression speak, to escape a character means to strip it of its special meaning and treat it like just a regular character. So let's drop in a backslash before our dot in our regular expression here and see what happens. And there you go. Now our regex is highlighting just the actual periods in our text, not every single character. We have successfully escaped the dot, which incidentally kind of makes the dot sound like a monster in a bad science fiction movie. I can almost see it. Escaping the Dot, starring Nicolas Cage. I don't know about you, but I'd watch it. Anyway, I majorly digress. Now, speaking of special characters, in the next video, we'll continue to dive deeper into regular expressions by exploring even more of those special characters. Brace yourself for the power of asterisks, plus signs, and maybe even a question mark or two. I'll see you there. Welcome back. So at this point, we should have the general idea of what regular expressions are and the very basics of how they work. At least, I sure hope so. Otherwise, I'm not doing my job very well, am I? So assuming that, now we're going to begin a series of deep dives into specific aspects of regular expressions. We'll start by learning all about using special characters in regular expressions, aka meta characters. Now, we've already seen one such special character already, the dot character we learned about in the last video. But while the dot character can stand in for basically any character, in this one we're going to drill down on a series of other special characters that instead stand in for specific types of characters. Namely, we'll be focusing on the following 5 special characters. First, \d, which represents any digit, basically any single number 0 through 9. \D, which represents any non-digit character. \w, which represents any alphanumeric character, so we're talking any letter or any digit. \W, which, you guessed it, represents any non-alphanumeric character. And finally, \s, lowercase s, which represents whitespace characters. Now, I know all of these weird little symbols can seem a bit overwhelming at first glance, but don't worry, we'll walk through each of them one by one. And just like last time, we'll illustrate these concepts using our trusty sidekick, the Pythex regular expression editor. So let's roll up our sleeves and get started. Okay, so back in Pythex, the first special characters we'll tackle will be \d and \d. Now to recap, \d is a special character that matches any digit from 0 to 9. To try this out, let's use a sentence that has a mixture of different types of characters, which I'll go ahead and just paste into our Pythex editor here. So this sentence reads, I have 7 cats, 2 dogs, and 17 fish. And as someone who owns 3 cats and 1 fish, I could add to this, and almost no money. So let's say we want to identify all the digits inside of this test string. up here in our regular expression box, we can just type \d, and look at that. Our regular expression highlights every single digit in our test sentence. You can think of this particular special character and special characters and regular expressions in general as a kind of spotlight that scans the text and stops to shine a light wherever it finds a particular type of character. Okay, but what if all of these numbers we're highlighting bring back bad memories of high school math class, and we instead want to find everything but numbers? Well, for that, we've got our \D special character. After changing our regular expression to that, you can see that every character in our test string that's not a digit has been matched. Okay, so now let's move on to our next pair of special characters, \w and \W. Now remember, \w is used to match any alphanumeric character, which means any letter, uppercase or lowercase, or digit. Let's test this out with the opening line of a certain famous text. It was the best of times, it was the worst of times. So typing that in our editor, and just to make things a little bit more interesting, I think I'll throw in a number at the beginning of our string. Let's say the year 2020. Although from my recollection, that was mostly the worst of times. So now if we type in our \w special character in the regular expression box, as you can see, our special character matches every single alphanumeric character in the text. Note that it didn't highlight the spaces, the commas, or the period at the end of the sentence. Now, by contrast, if we try the counterpart special character, \W, now only those spaces, commas, and the period are highlighted because this special character will match anything that isn't alphanumeric. All right, now let's move on to the last pair of special characters for this session, \s and \S. So when you're inspecting text data, spaces, tabs, and new line characters are often as important as the words themselves. And that's where these particular special characters come in. So let's try our \s special character on our modified Dickens quote here. And if you look closely at the match result, you'll see that all of the spaces in between words are highlighted, but the punctuation is not. Not only are the letters and digits ignored, so too are the commas and the period at the end of the sentence. And of course, you've probably figured out by now that if I change this lowercase s to an uppercase s, now everything but the white space will be highlighted as a match. And with that, you've now learned about some of the most common and fundamental special characters in regular expressions. But if you can believe it, we've really just gotten started exploring all the tools regular expressions give us for picking out complex patterns in text. As the next step in our journey, we'll go from matching types of individual characters to matching multiple characters at a time. That's coming up. See you then. Hey, welcome back. So now that we've explored how to search for individual characters in our regexes from every conceivable angle, from literal characters to wildcards like the dot character, to stand-ins like the special characters for letters, numbers, and so on that we saw in the last video, it's time to expand our horizons into searching for multiple characters at a time. And as with most things regex related, this turns out to be surprisingly straightforward. All we need is a pair of brackets. Now, the most straightforward example of searching for multiple characters at a time is probably using something called a character range. So what exactly are character ranges? Well, in simplest terms, they're a way of defining a range of characters that you're interested in matching within your strings. Let's start with ranges of digits or numbers. So imagine you're writing Python code to find all the ages mentioned in a document. Any number between 0 to 9, basically. Now, you could go about this the hard way, looping through all the characters in the text and testing whether they're numbers, but who has time for that, right? Well, that's where ranges come in. With ranges, you can express all of this in a much simpler, more concise way by putting the range of numbers in between square brackets like you see here, separated by a hyphen. It's really that simple. This neat little regex will match any single-digit number from 0 to 9. It's a whole lot cleaner and quicker than testing for them one at a time, wouldn't you agree? But ranges aren't just for numbers. They can also be used with letters. Suppose you're trying to match any single lowercase letter. In that case, you could write your regex like lowercase a hyphen lowercase z, of course inside of brackets. And you guessed it, you can do the exact same thing for uppercase letters too. In that case, you just change your regex to use an uppercase a and an uppercase z. But wait, there's more. You can also combine ranges. For example, if you wanted to match any single character that's either a lowercase or uppercase letter, you could do it like our first example here. Basically mashing those two ranges together inside of a pair of brackets. And to take this even further, you can even tack on 0 to 9, and in so doing identify uppercase letters, lowercase letters, and digits in one fell swoop. Now, while we're on the topic of all the cool stuff we can do between square brackets, what if, instead of a range of digits like 0 to 9, or a range of letters like A to Z, we want to test for a hodgepodge of different characters that aren't necessarily in sequence? For example, if we want to identify the letters T, L, or C, or the digits 1, 4, or 9, we could simply pack all of those characters in between square brackets. This will match any of the letters T, L, or C, and any of the digits 1, 4, or 9 in the target string. And if we find it more efficient to combine non-sequential lists of characters like this with ranges of characters like we've already seen, we can do that as well. So if we want to match T, L, C, 1, 2, or 3, our regex could be simplified to just TLC and then 1 to 3 instead of 1, 2, 3. Although, to be honest, this example would do a much better job of illustrating how that range can save the number of characters we need to type if the range of numbers were bigger. But hey, I kind of like the ring of TLC 1, 2, 3, so what do you do? Okay, so with that, I think I've had about all the slides that I can stomach. So let's step away from theory for a bit and dive right into some hands-on examples in PyThex. So back in PyThex, for our example, I've taken the liberty of creating a string that includes a number of single-digit numbers mixed in with some text. Here it is. So our test string is, I have 5 apples, 3 oranges, 7 bananas, and 0 kumquats. Aw, but I like kumquats. Oh well. So our job here is to use a regular expression to find all of the non-zero digits in this string. And we can use a character range to make the process nice and simple. In fact, it's as simple as 1 to 9. So let's go ahead and type that in between brackets, of course, and see what we get. And sure enough, Our numbers 5, 3, and 7 are matches, but our regular expression does not give me that painful reminder that I have 0 kumquats. Okay, so we've now seen how to use ranges to match numbers. But what about letters? Well, here's another little string for us to experiment with. Or maybe a not-so-little string. It's a bit of a mess, isn't it? Imagine this is a slice of a log file or something. It's not beyond the realm of imagination if you've dealt with log files, believe me. So let's say we want to find any instances in this jumbled up string of characters where a lowercase letter immediately follows a number. So first, we'll type our regex that captures any digit. So I'll change that 1 to 9 to be 0 to 9. And then we'll follow that with our regex for lowercase letters. Now note here that we're now combining 2 distinct patterns into a single regular expression. So this is actually an extremely common practice when using real-world regexes, which can get almost absurdly long and complex when testing for really intricate patterns. But don't worry, we're not going to tackle anything like that just yet. So back to our example, if we look at the highlighted matches, it appears that this incredibly simple little regular expression was able to find every instance in our text string where a lowercase letter followed a digit. 3 lowercase a, 6 lowercase x, and 9 lowercase d. And if we wanted to switch up our example slightly and search for any instances where, say, a capital letter follows a lowercase letter, that turns out to be equally straightforward. We just need to use the uppercase spin on that A to Z character range in tandem with the lowercase version. So we'll say lowercase A to Z followed by uppercase A to Z. And just like before, it works like a charm. If you look at our 3 matches, we have a lowercase c followed by an uppercase j, a lowercase z followed by an uppercase c, and a lowercase f followed by an uppercase g. Now it's worth noting that combining different ranges in this way, enclosed in their own respective sets of brackets, ends up creating a kind of this and that proposition. In order for our overall regular expression to find a match, there must be a lowercase letter followed by an uppercase letter. But if we move both of these character ranges inside of a single set of square brackets, which I can do just by deleting these 2 in the middle here, now our AND proposition becomes an OR proposition. All letters in our sequence of characters, whether upper or lowercase, are now matched. And that's because when we put multiple character ranges inside of a single pair of brackets, our regular expression will match anything from the text string that matches any of those character ranges we defined. In other words, it looks at those ranges individually, not as a combined sequence like our previous example when we had each regex inside of its own distinct pair of brackets. Now, incidentally, this same principle applies to plain old character strings too, not just character ranges. Let's say I wanted to find any of the following in our test string: a lowercase y, a capital V, or the number 7. Well, our regex would be as simple as, inside of our square brackets, lowercase y, capital V, and the number 7. And as you can see, any instances of any of those characters have been matched by our regular expression. Now, it turns out that you can actually combine individual characters like these with character ranges to achieve the same kinds of results, but sometimes more efficiently. So if I still wanted to look for a lowercase y or a capital V, but instead of 7, I wanted to see any numbers between 4 and 9, I could do this the hard way, by by spelling out all the individual characters. So that would look like me replacing this 7 here with 4, 5, 6, 7, 8, 9. And that does in fact do the trick. But it's much easier to just combine a character range with my 2 letters of interest. So I'll get rid of everything between 4 and 9 here, and just put a hyphen in between those 2 numbers. And look at that. This works just as well and with half the typing, which is always a good thing. All right, so we've seen how to use brackets to match specific sets and ranges of characters. But what if we want to do the opposite? That is, what if we want to match everything except a specific set or range of characters? Now, this is actually a lot easier than it sounds. It literally requires us to type one single additional character just inside of our opening bracket. A caret. Not C-A-R-R-O-T, C-A-R-E-T. That weird little upward arrow character on your keyboard that you probably don't use very often. So as an example, I'll paste something into PyThex that is a lot like what I would post on social media if I posted much on social media. So pasting that in, we see that our test string is, just enjoyed a full English breakfast. 3 eggs, 4 rashers, 2 bangers, toast, mushrooms, tomatoes, potatoes, and of course beans. Pound best life, pound food coma, pound wake me later, at fun foodies, at Gordon Hamzy. Whew, that is a lot of food. But hey, at least I had those tomatoes and mushrooms to keep things healthy, right? Now let's say we want to identify anything in this pseudo tweet that isn't a lowercase letter, isn't an uppercase letter, and isn't a digit. Now doing that is literally as simple as defining a regular expression to find those things. So up in our regular expression box, we'll type lowercase a to z, uppercase a to z, and then 0 to 9. And now, to look for anything that isn't any of these things, just after our opening bracket, if I can find it on my keyboard, I'll type that weird little caret character. And sure enough, looking at our match results, all of the spaces and punctuation are highlighted, but none of the numbers, uppercase letters, or lowercase letters. So with just 12 characters, you were able to define and search for a pretty darn complex and specific pattern. Not half bad for a relative regex rookie, right? Okay, so we've learned a lot about regexes so far, but there's a lot more to come. Up next, we'll explore quantifiers, a way to look for specific quantities of characters or ranges of characters in our regular expressions. See you then. Welcome back. So in this one, we're going to continue our exploration of regexes by introducing you to quantifiers, another absolutely essential tool in your regular expression toolkit. Now, what are quantifiers exactly, and why are they so important? Well, quantifiers, in regular expressions, allow us to specify the quantity, or the number of times, a certain character should appear. This becomes incredibly handy when we're dealing with patterns that repeat or may have optional elements. So in this one, we'll be focusing on 3 such quantifiers: the asterisk, the plus sign, and the question mark. Each of these has a special meaning and use case when used in regular expressions. Let's start with the asterisk. In the context of regular expressions, the asterisk quantifier indicates that the character immediately before it can appear any number of times in the pattern, including 0 times. That's right, the character could be completely absent and the pattern would still match. Next up, the plus sign. This quantifier is similar to the asterisk, but with one key difference. It indicates that the character immediately preceding it should appear one or more times. So unlike the asterisk, the character cannot be absent in this case. Finally, we have the question mark. This quantifier indicates that the character preceding it can appear either once or not at all. So it's optional, but if it appears, it can't appear more than once, at least as a match to the pattern we specified. Understanding these quantifiers and when to use each is fundamental to harnessing the power of regular expressions. So let's now look at these quantifiers in action with some hands-on examples. We'll start our exploration of quantifiers with the asterisk. Now, as we've just learned, the asterisk means that the character before it can appear any number of times in the pattern, including not appearing at all. So now suppose we have the following text. I love coding in Python. Notice the enthusiastic use of in Python. Incidentally, when I said I love coding in Python at the Grand Canyon, I mean, don't we all like to publicly proclaim our love for programming languages while on vacation? The echo sounded a lot like this. Okay, so back to our example. Now let's see how we can use the asterisk quantifier to match Python no matter how many ends are in our test string. So our regular expression will just be Python followed by an asterisk. Now, when you look at the match result here in Pythex, you'll see that our regular expression successfully matched all of Python. The n asterisk part of our regular expression is saying match an n 0 or more times. So it handles any number of n's following Python. But what happens if we remove all the n's from our test string? So we'll change that test string to I love coding in Pytho. And now we can see that our regular expression still matches Pytho because, again, that asterisk allows for 0 occurrences of n. All right. Now that we're acquainted with the asterisk quantifier, let's move on to the plus sign quantifier. Recall that the plus sign indicates that the character immediately before it should appear one or more times. Now we'll start with the same example. So I'll just go ahead and swap those n's back in. But this time our regular expression will be Python plus instead of Python asterisk. Now as you can see here, this regular expression also matches Python because the n plus part of our regular expression is saying match an n one or more times. But remember that there's a key difference between the plus sign and the asterisk. So let's change our test string again to I love coding in Pytho. So now our regular expression doesn't match anything in the test string. And that's because the plus sign requires at least one occurrence of the character before it. In this case, the letter n. So when n is completely absent, the pattern doesn't match. So now that we've covered the asterisk and plus sign quantifiers, let's explore our final quantifier, at least for this video, the question mark. Now this quantifier, if you recall, denotes that the character immediately before it can appear either once or not at all. So let's again go back to our original test string, but this time our regular expression will be Python question mark. And looking at our match result here, you'll see that our regular expression just matches Python, but not all those extra n's after Python. That's because the question mark denotes that the character before it can only appear once or not at all as a match to our regular expression. Now to prove the other side of this, let's again change that test string to I love coding in Python. Incidentally, Python actually kind of sounds like a hip, edgy name for some fancy new programming language that everybody will say is the greatest thing ever. If you start seeing Python tutorials out there soon, remember that you heard it here first. Anyway, back to good old-fashioned Python in our Pythex editor. Now our regular expression still matches Python. As we expected, since the question mark allows for 0 occurrences of n, the character directly before it. And now if we change our test string to just I love coding in Python, our regular expression matches Python too, because again, that question mark quantifier allows for 0 or 1 occurrences of n. Okay, so with that, you now have a working understanding of the big 3 quantifiers in regular expressions. The difference between them may seem small, but their unique behaviors give us a powerful way to describe different patterns when we're crafting regular expressions. So now that we've had a chance to explore each of these quantifiers individually, let's briefly see an example of how they can be combined with special characters to create even more powerful regular expressions. Suppose we want to match any string of digits followed by 0 or more exclamation marks. So for our regular expression, we can start with the special character for digits, which is simply \d, and then follow that with the plus sign quantifier, indicating that we want to match patterns consisting of at least 1 digit. Then we'll follow that with an exclamation mark, and then an asterisk, indicating that we want to see 0 or more exclamation marks following that string of digits. Now for our test string, I'll go with the meaning of life is 42, with a bunch of exclamation marks after that for emphasis. So I'll just paste that in. And as we can see, our regex matches the number 42 and all the exclamation marks after it, since that series of characters consists of 1 or more digits and 1 or more exclamation marks. So now let's try another test string. And this one will just be a phone number that I'll choose completely at random. So I'll say 867-5309. That phone number actually does seem familiar somehow, but oh well, never mind. So this time, looking at our match result, both sequences of numbers within this phone number, excluding the hyphen, still match, since an exclamation mark isn't strictly required by our regex. Now as a final test string, I'll just paste in no digits or exclamations here. And as you can see, our regex doesn't match anything in this test string, since the pattern we define requires at least 1 digit. Okay, so that's a wrap on quantifiers. For this video, that is. But in the next one, we'll look at a way to create our own custom quantifiers, for when you find the options presented by the 3 little symbols we played with here just a bit too limiting. I'll see you there. Hey, welcome back. So as you might have guessed, there's more to quantifiers and regular expressions than just what we learned in the last video. And in this one, we'll be digging into a way to define our own custom quantifiers using curly brackets, also known as curly braces. These braces allow us to specify the exact number of occurrences we want to match, or even a range of occurrences. If you ever find yourself in a situation where you want to match a pattern, but only if it appears exactly this many times, curly braces are there to help. So, what exactly do we mean when we say that curly braces are quantifiers and regular expressions? Well, in the context of regexes, quantifiers dictate how many instances of a particular character must be present in order for a match to be found. Now, we already looked at how the asterisk, plus sign, and question mark quantifiers allow us to specify anywhere from 0 or 1 to an unlimited number of occurrences of a specific character. Well, curly braces take this a step further by allowing us to specify an exact number of repetitions or a range of repetitions. Here's how it works. If you write an integer inside of a pair of curly braces following a character in your regular expression, your regex will match exactly that number of repetitions of the character preceding the braces. So for example, A followed by a number 3 inside of curly braces will match the string AAA, but not AA or, and I'll spare you from hearing me say A 4 times, 4 A's. But you can also specify a range by writing 2 numbers inside those curly braces, separated by a comma. In the case of our abstract example here, where n represents the first number inside the braces and m the second, this would match at least n and at most m repetitions of the preceding character. So for a more concrete example, the letter A followed by 2, 4 inside of curly braces would match AA and also AAA and also 4 A's, but it wouldn't match a single A and it wouldn't match 5 A's since those repetitions of the letter A are outside the specified range. Finally, if you just provide a single number followed by a comma, like our first example here, n, comma, that means match n or more repetitions. So A followed by the number 2 and then a comma and then nothing else after the comma inside of curly braces would match 2 A's, 3 A's, and however many A's I have in this third example. You get the idea. Okay, so now that we have a basic understanding of how curly brace quantifiers work in regexes, let's move on to some practical examples in Python. For our initial example, I'll paste in a simple string of repeating letters. And now, for our regular expression, let's say we want to match sequences of the letter A if and only if there are exactly 4 in a row. To write a regex for this, we'll start with the letter A as our character of interest, and then follow it with the number 4 inside of curly braces to denote that we want exactly 4 repetitions. Now, as you can see, our regex successfully matched the sequence consisting of 4 A's in our test string. But what would happen if I added a couple of A's at the end of our test string? Nope, our regex is not interested in those. It's specifically looking for a sequence of 4 consecutive A characters. Now, if I add a 5th A to this sequence of 4 A's at the beginning of our test string, again, our regex just matches the sequence of 4 A's. And note that it matches the first instance of that it's able to find. Now, what if we wanted to match a sequence of A characters that occur between 3 and 5 times in a row? For this, we can swap out our 4 for 3, 5. And now that sequence of 5 A's at the beginning of our test string is a match. And if I add a 3rd A to that sequence of A's at the end, sure enough, that's a match as well, since our regex is looking for sequences of A's anywhere from 3 to 5 in length. Okay, so now let's test the third and final flavor of custom quantifiers, in which we match n or more occurrences of a given character. We'll continue with our same test string, but this time we'll search for 3 or more consecutive D characters. So now let's change our regular expression to match sequences of the letter D that occur 3 or more times in a row. So I'll swap our A out for a D, and then I'll simply just delete our 5 here. And now our regular expression is able to match that sequence of 5 Ds in our test string. And if I add another D, that's matched. And if I add another one, that's matched as well. Or if I reduce the number of Ds all the way down to 3, we've still got a match. But then if I delete one more, no match, since our regular expression is looking for a sequence of at least 3 D characters. Now, as a final, somewhat more practical example, let's try using curly braces in tandem with one of our special characters to match a typical 10-digit phone number in the United States. So for our test string, I'll type 859 867 5309. And now, so our regular expression has to pick this phone number out of a larger test string, I'll plug this phone number into the context of a sentence. So I'll say, is this number a real phone number? So now let's think through how to define a regular expression to match this phone number inside this test string or any other test string we might encounter. So first I'll use the special character that represents any digit, which is \D. And of course, right away, this matches all the individual digits in the test string, but it's not matching our entire telephone number as a whole. So thinking about the structure of this telephone number, we really want it to begin with exactly 3-digit characters. So after \D, inside of curly braces, I'll punch in the number 3. Then I'll add a hyphen. And now because we expect the second part of that phone number to also always be 3 digits, I'll pretty much just repeat the first part of our regex. So \D, a pair of curly braces, and the number 3. Then another hyphen. And finally, to match the last component of the phone number, and you've probably guessed where this is going at this point, it'll just be \D, a pair of curly braces, and the number 4. And sure enough, this regular expression matches our entire phone number, but only our phone number. And if we change the phone number to something else, say we change that 859 to a 502, our regex still works. All right, so that wraps up our exploration of quantifiers and regular expressions. As you've seen, these powerful symbols can add a ton of flexibility and specificity to your pattern matching. But we're not done with regular expressions just yet. Next up, we'll delve into another tool that will add more precision to our regex toolkit: the use of anchors, which will help us define where in a string our pattern should match. See you then. Welcome back. So now that we're getting comfortable creating regular expressions to match specific patterns in a text string, it's time to take things a step further and see how to specify where that match occurs. And we can do this with something called anchors. So what are anchors? Well, they're special characters that allow us to define boundaries or specific positions within the strings we're searching. In this video, we'll be focusing on two of the most widely used anchors: the start of string anchor, which is this little upward pointing arrow character called a caret, spelled C-A-R-E-T, and not like those carrots that you dip in ranch dressing. And then also the end of string anchor, which is more simply just a $sign. Now, why are these useful, you may ask? Well, let's think about a real-life scenario. Say you're validating user input, and you need to check if a string is exactly a specific word. Without anchors, if you search for the word dog in the string I have a dog, the search would return a match, even though the user didn't input exactly DOG. However, by using anchors, we can ensure that we only get a match when the input is exactly what we're looking for, no more, no less. So let's get started and see these concepts in action. We'll start with an example using the start of string anchor, that weird little caret character. Say we want to find strings that start with the word hello. Without this anchor, our regular expression might match strings that contain hello anywhere, not just at the start. For instance, let's say we have the string hello world, hello universe. Now, if I enter a regular expression consisting of just the word hello, we find two matches, one at the start of our test string and one in the middle. But again, what if we only want to match the hello at the very beginning of the string? Well, that's where that start of string anchor comes into play. So if I punch that little caret character at the beginning of our regular expression, now, by updating our regular expression to caret symbol hello, we only match the hello at the start of our test string. Now, the end of string anchor, the $, works similarly, but it matches the position at the end of the string. So now let's say we want to find strings that end with the word universe. Well, I could start by just typing out the word universe as my regular expression, and that seems to work, but does it really? Because if you look carefully at our test string, it actually doesn't end with the word universe. It ends with a period. So really, if the goal is to only match a pattern in which a string ends with the word universe, our regular expression shouldn't be matching anything here. So now, to get it to do what we want it to do, let me add that $, and suddenly it's unable to find a match. But if we remove this period at the end of the second sentence, so that our test string truly ends with the word universe, now our regular expression is able to find a match. Okay, so next up, let's look at how these anchors can be used together to match an exact string as a whole, and not just the beginning or the end of a string. So as our example, let's say we're working with an extremely common scenario, validating user input. In this case, we want to check if a user has entered a valid 5-digit zip code. To start, for our test string, I'll type in 90210, which is, if memory serves, both a valid zip code and one full of great drama and intrigue. Kind of embarrassed that I'm old enough to remember that, but oh well. Hopefully you're too young to get the reference. Anyway, back to actually, validating this zip code. If we use the regular expression \d followed by the number 5 inside of curly braces, that will certainly match this string, since we're literally saying, look for any pattern that consists of 5 consecutive digits. But what happens if we have something a bit messier as our test string? So what if I change our test string to my zip code is 90210, comma, not 12345. Now, the regular expression we just entered matches both 90210 and 12345. But we don't want to extract zip codes from the middle of sentences. We want to validate input that should only contain a single 5-digit zip code. Now this is where our anchors come to the rescue. So let's add that little caret symbol to the beginning of our regex, and then a $sign to the end of it. So by updating our regular expression thusly, we are indicating that we want to match a string that consists of 5 digits, nothing more, nothing less. And now our regular expression is failing to match our test string, as it should. But if we change our input string back to just 90210, now it matches. So just as we hoped, using these two anchors together allows us to match an exact string, making them perfect for validating user input or checking if a string follows some certain format. All right, so as much fun as it's been playing around in this convenient little Python sandbox, we haven't been able to use our newfound regex prowess in the context of, actual Python code. The reason we're all here, right? Unless you're here for my corny, dated cultural references, but let's face it, probably not. So in the next one, we're going to see how we can use Python's RE module, that's RE for regular expressions, to work with regular expressions using our favorite programming language. I'll see you there. Welcome back. So we've already come quite a long way in understanding the powerful tool that is regular expressions. We've learned about special characters, quantifiers, and anchors, among other things, all of which allow us to create complex patterns to match against strings. Now, so far, all of our pattern matching has taken place on the Pythex website, which is a great tool for learning and experimenting. But the real power of regular expressions comes to life when we use them directly within our Python code to automate tasks. And that's why we're now going to dive into Python's built-in RE module, which contains a ton of tools that allow us to work our regular expression magic using everybody's favorite programming language named after a giant predatory snake. More specifically, in this video, we're going to zoom in on two very important methods from that RE module: search and group. The search method lets us search for a match to a specified pattern anywhere inside a string, while the group method helps us extract the part of the string where there was a match. Okay, so without further ado, go ahead and fire up PyCharm, or your code editor of choice, and let's get started slinging some code. So here in PyCharm, let's start by creating a new project for this section, which I'll call Regular Expressions. Now, inside of our newly created project, I'll create a Python file called regex search group. Now, inside of this file, the first thing we need to do is import that RE module I mentioned a moment ago. Now, since this is a built-in Python module, we don't need to install anything extra. So let's go ahead and import that on the first line here. All right, now that we've imported the RE module, we're all set to start using it. And our first task along those lines will be to use the search method from the RE module to identify whether a search pattern, that's our regular expression, exists within some target string. Now, the search method takes two arguments. First, the regular expression pattern that you want to search for, and second, the string that you want to search within. Then, if the search method finds a match, it returns a match object. Otherwise, it simply returns none. Now let's try this out by defining a simple string and a pattern to match. So let's say our string is a classic joke, at least to me. So I'll say joke equals, and then paste in, I remixed a remix, it was back to normal. Now our search pattern, or regular expression, for this example, will just be the word remix. In other words, we're really just searching for the word remix in this text string. So now down below this, I'll say match equals re.search. And again, that first argument is going to be our search pattern or regular expression, which in this case is just the word remix. And the second argument will be our text string that we're searching inside of, which is in our joke variable. Okay, so now we have our match object stored in the variable match. But how do we know if the search method actually found a match? Well, one simple way is to use conditional logic to check to see if the value in that match variable is none. If its value is none, that means we didn't find a match. Otherwise, we did. So let's set up a simple if statement with that conditional logic. So I'll say if match is not none, then print we found a match. And otherwise we'll print no match found. Now running our code, sure enough, our console output confirms that the search method was able to find a match. Okay, so now let's switch gears and jump into the search method's best friend, the group method. So this method is used to get the actual content of the matched pattern from the target string. So now let's go ahead and use the group method on the match object that was returned by the search method, and then print the result. So down below our if statement, I'll say print the match is, and then we'll call the group method on that match object. So we'll say match dot group. So now running our code once again, sure enough, it's confirmed that the piece of text that matched our search pattern was the word remix. But one thing you might be wondering here is, why did group only return one instance of remix when remix actually appeared twice in our target string? Well, by default, the search method simply returns the first match it finds. So is there a way to override that default behavior? We'll see soon enough. Hint, there totally is. Speaking of which, this little example showed us just a hint of what you can do with the RE module in Python. So now let's ramp things up a bit and start to incorporate some of the regex patterns we learned in previous videos. We'll tackle that in the next video. See you there. Hey, welcome back. So picking up right where we left off in the last video, in this one, we'll apply some of the regex knowledge we've acquired throughout this section, but in the context of actual Python code. Let's consider a string that has a series of alphanumeric codes separated by spaces. First up, I'll comment out all of our code here except for the line where we import the RE module. And now, rolling down our file, let's consider a string that has a series of alphanumeric codes separated by spaces. So I'll go ahead and drop an example of this into a variable I'll call codes. Now suppose we're interested in finding any code inside of this string that starts with a number and is followed by any number of alphanumeric characters. Of course, as I'm sure you know by now, we can construct a regular expression pattern to do just that. So we learned earlier on that the special character \d matches any digit, while \w matches any alphanumeric character. That is to say, a number or a digit. So the pattern we're interested in, as I said a moment ago, is a digit followed by one or more alphanumeric characters. So the pattern must start with a number, after which we can have any series of numbers or letters. Now, to get that any series of numbers or letters piece, we can use the plus sign quantifier to denote one or more alphanumeric characters. So to get this working, let me create a variable called codeMatch. And here, I'll again invoke our re.search method. And then inside of this, our regex pattern is going to be \d, followed by \w, and then that plus sign, and then a comma, and then we're just searching inside of that string that's in our codes variable. And now below this, I'll print the result of calling the group method on that match object stored in the codeMatch variable. So I'll say codeMatch.group. Now before we run this, remember that the search method only returns the first match it finds. So when we print codeMatch.group, what we should see here is 123 ABC, which is the first code in our test string that starts with a number followed by a series of alphanumeric characters. So let's go ahead and run this code and put that to the test. And indeed, that is the match that is returned by the group method. Awesome. So now that we have the basics of identifying and extracting regex matches using the search and group methods down, let's turn things up a bit with our next topic, working with multiple groups. So it turns out that when we enclose chunks of a regular expression inside of parentheses, the group method can take one or more numerical arguments to return those corresponding chunks from the regex. Now I know that may sound a little bit tangled, so to illustrate this, let's start with a brand new example. So I'll once again comment out these lines of code, and then roll down a bit further in our Python file. Now suppose we have the following text that I'll drop into a variable that I'll call test string. And that text is, the MacGuffin will arrive on June 21st, 2023. So now let's say we want to extract the month, day, and year from this string all as separate elements. So as I alluded to a moment ago, we can use parentheses in our regular expression to create separate groups for each of these elements. Now our basic regular expression pattern, which this time I'll put in its own variable that I'll call regex, will be first, one or more alphanumeric characters for the month, which I can denote with \w, then a plus sign, and then a space, followed by one or two digits for the day of the month, which I can denote with \d, and then a pair of curly braces, and then inside of those, 1, 2, to indicate that we want to see either one or two digits, and then a space, and actually I'll want a comma after that day of the month as well. And then finally, we just want 4 consecutive digits for the year. So that will be \d followed by the number 4 in curly braces. And now to make sure that this value is interpreted literally, exactly as we typed it, I'll convert it to a raw string by just putting the letter R directly before that first quote. But now, with our core regular expression in place, here's the new spin we're going to apply to the same old formula. We're going to enclose each date component, or at least the pieces of our regex intended to match those respective components, within parentheses. So that will be this first piece that's meant to grab the month, this second piece that's meant to grab the day of the month, and finally, this third piece that's meant to grab the year. Note that I'm not including extraneous characters like the spaces between those components or the comma inside of those parentheses. I'm only enclosing the individual pieces that I ultimately want to fetch back out. Now, it's important to note that adding these parentheses will not affect how the regex matches patterns within the target string in any way. The parens are effectively invisible in that sense. But those parentheses will allow us to access the pieces of the match corresponding with the parts of our regex inside of those parentheses, using the group method. Okay, so with our regex in place, let's first see what happens when we use the group method without any arguments, just like we've been doing all along. So I'll say match equals re.search, and then our first argument will be our regex, and our second argument will be test string, and then we'll just print the group method, which we'll call on the match object. So I'll say match dot group. So now running this code, here, as with our previous examples, we get the entire match. So at least we know our regular expression is working. But here's where things get interesting. If we call match.group with an integer as an argument to the group method, we get the group from our regular expression, defined by those parentheses we added, corresponding with that number. In other words, calling match.group and passing 1 to the group method should return June. Then calling match.group with 2 as the argument should return the number 21. And match.group with 3 as the argument should return 2023. You get the idea. But just to prove that to you, let's see that in action. So for our first line, I'll say month, comma, then match.group 1, and then I'll just copy and paste that a couple times. And for our second, I'll say day, and then match.group 2, and then for our third, I'll say year, and then match.group 3. Now running our test code one more time, and then scrolling up our console so we can see the output, we now have confirmation that we were able to pull those individual components out of our regular expression into their own discrete pieces of data. So now we've gone from simply finding patterns within text to actually being able to do useful things with them. All right. So we just saw a pretty cool example of returning multiple discrete pieces of data from a string based on a single regular expression. But we still haven't addressed the conundrum we encountered earlier. If there are multiple matches to our regular expression as a whole within the target string, how do we return all of those matches? Well, in the next video, we'll discuss exactly that. We'll be covering the Findall method, which allows us to extract all occurrences of a pattern within a given text string. I'll see you there. Hey, welcome back. So in this video, we're going to explore yet another powerful method provided by Python's RE module, the Findall method. That's all one word, by the way, as you can see here. Much like the search method we encountered in the last video, Findall allows us to match regular expressions. But unlike search, which returns the first match it finds, Findall is a bit more thorough. True to its name, it returns all the matches within a string, making it an indispensable tool when we want to extract multiple pieces of information from a text string. So with that, let's go ahead and dive into PyCharm to see some examples of Findall in action. So back in PyCharm, I'll create a new Python file called Regex Findall. So now that our file is set up, let's begin, just like in the last video, by importing the RE module. Okay, so we're now ready to delve into the Findall method. Let's start by digging just a little bit deeper into how it works. So again, much like the search method, Findall allows us to match regular expressions within a string. However, while search stops after finding the first match, Findall takes it a step further. This method will find all occurrences of our regex pattern within the string and then return those as a list of strings. Again, this can be extremely useful in cases where you want to fetch every single match you find in a long piece of text. Now, the syntax for the Findall method is simple. It works pretty much just like search. We pass two arguments to it. First, a pattern, which is the regular expression we're searching for, and then, of course, the string that we're searching within. Now, something to remember here, Findall does not return match objects like the search method does. Remember how we had to use the group method on match objects to extract the actual matches? Instead, Findall returns a list of all matches as strings. And then if there are no matches, Findall simply returns an empty list. Okay, so with all that said, let's see this in action by working through a couple of code examples. For our first one, let's consider a simple case where we have a string containing a few dates, and we want to extract all the years from this string. So for that text string, which I'll drop inside of a variable called text, we'll have the World Cup of 1998 was hosted by France, the next edition in 2002 was hosted by South Korea and Japan, the most recent one in 2022 took place in Qatar. Now again, our goal here is just to extract all the years from this text string, which are simply 4-digit numbers. Using techniques we learned in previous videos, we can represent a 4-digit number in a regular expression simply as the \d special character followed by the number 4 in curly braces. So I'll go ahead and create that pattern on the next line and drop it inside of a variable I'll call regex. And again, a best practice, especially when you're putting a regex pattern inside of a string that you're assigning to a variable, is to make that string a raw string by putting the letter R in front of it. So with our test string and our regular expression in place, we're ready to see how Findall can help us extract all the matches for this pattern inside of our test string. As a first step, we'll call the Findall method on the RE module, just like with search, and pass our pattern and the string as arguments. So I'll say years equals re.findall, and then our regex will be our first argument, and our text string will be the second. So now to see what this yields us, I'll just print the content of the years variable, and then run our code to test. And sure enough, down in the console, we see the years 1998, 2002, and 2022, each extracted from the string and stored in a list. The Findall method successfully found all occurrences of our specified pattern. And again, note how we got a list containing all those matches and how the order of the matches in the list reflects the order in which they appeared in the string. It's also worth reiterating that Findall returned the matches as strings, not match objects, which makes them a little bit more ready to use or manipulate further using Python's many string methods. Okay, so now let's move on to another example to see how Findall works with somewhat more complex patterns. So I'll first comment out our code here, and then roll down a few lines in our Python file. So now, let's say we have a long string of text containing various animal sounds, and we want to find all the sequences that resemble a cat's meow sound, but with varying numbers of O's and W's. Our string, which I'll again drop inside of a variable called text, consists of the cat goes meow, 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 meow. My apologies for the terrible impersonation of a cat. You'd think I could do better considering I have 3 of them. And then, while the dog goes woof. So again, our goal here is to find all sequences that start with the letters ME, followed by 1 or more O's, and then ending with 1 or more W's. We can represent this in a regular expression as, and I'll go ahead and type out my regex here, ME, and then the letter O followed by a plus sign, indicating that we want to see 1 or more O's, and then the letter W, also followed by a plus sign, indicating that we want to see 1 or more W's. So now I'll convert that to a raw string, and then with that regex in place, I'll create a variable called sounds to hold the output of our findall method, and then I'll call that method on the RE module. And of course, I'll pass our regex string as the first argument, and our text string as the second. And then of course, I'll print the result just to see what we got. So now running that code, we see a list of all the meow variations inside the string. Findall was able to find and return matches of varying lengths, and the output list again preserves the order in which those matches were found in the string. Nice. All right, so now that we've learned how to find all of the matches for a regular expression in a piece of text, it's time to look into something useful we can do with those matches. Replace them with text of our own. That's coming up next. I'll see you then. Welcome back. So in this one, we're going to follow a natural transition from simply finding all the matches for a regex in a text string to replacing those matches with our own custom text. And we'll do this using another incredibly useful method provided by the RE module, the sub method. This sub method, short for substitute, can be an invaluable tool in your Python automation toolkit. As the name suggests, it allows us to substitute or replace portions of a string that match a particular pattern, something that's extremely useful when working with large bodies of text or when cleaning and standardizing data. So let's go ahead and dive into PyCharm and work through some examples to see just how powerful this sub method can be. So now, back in PyCharm, I'll first, of course, create a new Python file for this video, which I'll call regex sub. Now, inside of this file, let's go ahead and get that RE module imported. Okay, with all the usual setup out of the way, let's talk a bit more about the sub method itself. So in the same way that the findall method is used to find all matches to a pattern within a string, the sub method takes that a step further by substituting all occurrences of a pattern within a string with a replacement string. It works a lot like the replace method on Python's string objects, but it's much more powerful because it allows us to use regular expressions to define the text we want to replace. The syntax of the sub method is pretty straightforward, especially if you've already been playing around with methods from the RE module like we have. Like search and Findall, it takes a regex pattern as its first argument, but then the twist is the string that we're searching within is the third argument of the sub method. So what's the second argument? Well, that's where you specify the text you want those matched patterns to be replaced with. And finally, once you've passed those arguments to the sub method, it simply returns the result of finding and replacing all those matched patterns. In other words, it's kind of like an advanced Pythonic version of doing a find and replace in an email or a text document. Okay, so now that we've got a basic understanding of how the sub method works, let's put it to good use, shall we? So let's say we have a string containing multiple email addresses, and we want to anonymize them, replacing the username part of each email address with simply user. We can start by defining our target string and the regular expression pattern that we want to match. So first up, I'll paste in our target string, which I'll drop into a variable called text. So I'll say text equals contact us at info@example.com or support@mywebsite.com. So then, for our pattern, since the username we're looking for consists of any number of consecutive alphanumeric characters followed by an @ sign, I'll say \W for alphanumeric character, followed by a plus sign to indicate we want one or more alphanumeric characters, and then finally, that @ sign. And then I'll put an R in front of this to make this a raw string. So again, this pattern we see here represents the username parts of the email addresses that we ultimately want to replace. So now with this pattern established, we can call the sub method to replace all occurrences of this pattern within our target string. So next, I'll create a variable called anonymized text to hold the return value of our sub method. Boy, I sure do hope I spelled that right. And now, to that very difficult to spell variable, I'll assign the result of calling the re.sub method, to which I'll first pass our regex pattern, and then the text we want to replace that pattern, which is simply the generic username user @, and then as our final argument, we'll just pass in our target string that we're replacing those usernames in. And then, of course, to make sure this is working like we hope, I'll just print the value of anonymized text. So now, when we run this code, we see that those email addresses have been converted to user@example.com or user@mywebsite.com. In other words, all email usernames have in fact been replaced with user, effectively anonymizing those email addresses. So as you can clearly see here, the sub method is incredibly useful when we want to replace specific patterns within a string. Its ability to work with regular expressions makes it a very powerful tool for string manipulation in Python. But even so, it turns out that we can take the power of the sub method to a whole nother level using something called back-referencing. So in the context of regular expressions, a back reference is a way to refer back to matched groups in your pattern. Now, as you probably recall, when we write a regular expression and put a portion of it in parentheses, we're creating a group. Well, the cool thing is that these groups can then be referenced in your substitution string using a special notation. in which the group number stands in for the actual matched text. This is useful when we want to include one or more matched groups as part of our substitution text. Let's see how all this works with just one more example. So first I'll comment out everything under our import statement, and then roll down our Python file just a bit. So say we have a text string that contains some dates in the format month, day, year, and we want to convert them to the format year, month, day. Then, assuming the dates in our target string have their components separated by slashes, to make things even more interesting, we'll use hyphens as the separators in our substitution string. So first, as per usual, let's define our target string and the regular expression pattern that we want to match. But this time, not quite per usual, we'll use parentheses to create groups in our regular expression. Now first up, I'll create a variable called text to hold our target string and then paste that right in. So I'll say text equals, and then paste in that string. And as you can see, our dates in this string are formatted month, day, year, with those components separated by forward slashes. So now for the regex, which I'll call pattern, our pattern here will consist of 3 groups: the month, the day, and the year. Each group, of course, will be surrounded by parentheses, and our regex will use the \d special character in tandem with those curly brace quantifiers we've gotten so familiar with to build out the actual pattern of the regex. So for the first piece, we'll say \d, and then a pair of curly braces, and the number 2, and then a / literal, and then another \d, another pair of curly braces with 2 inside of those, and then yet another /, another \d, another pair of curly braces, but now with a 4 inside of those to denote the year. But now the twist is, I'm going to wrap each of these components inside of parentheses, so they're defined as groups that we'll later be able to access in our substitution string. So I'll just wrap the month, the day, and the year inside of parentheses, and note that I'm not wrapping the / separators inside those parentheses since I don't need to access those after the fact. And then as usual, I'll make this whole thing a raw string. So at this point, we're ready to call the sub method to substitute our pattern. But instead of a simple string, we'll use a string with those back references I talked about earlier that will refer to the individual groups within our pattern. This will allow us to rearrange those groups, in other words, the components of the date, in an entirely new way. So how that will work is actually pretty straightforward. In our replacement string, a back reference consisting of \1 refers to the first group, which is the month. \2 will refer to the second group, which in this case is the day. And \3 will refer to the third group, which of course is the year. Then we'll simply rearrange those groups in our replacement string and separate them with hyphens instead of forward slashes to get the dates in our desired format. So now that we know generally what we're trying to accomplish, I'll create another variable called formatted text. And to this, I'll assign the result of the re.sub method, to which I'll first pass our regex pattern, but then as the second argument, and this is where things get interesting, I'll use that back reference to refer to our third group, which is of course the year, followed by a hyphen literal, and then \1 to back reference that first group in our pattern, which represents the month, and then another hyphen literal, and then finally \2 to reference the group in our pattern representing month. Now this is a fairly sophisticated pattern, so to make sure we don't run into any problems, I'll turn this into a raw string. And then finally, as the third argument of the sub method, I'll just pass in our original text. And then of course we'll need to print the result to test. So I'll just say print formatted text. So now, running our script, we have an error. Oh no. It's saying we have an unbalanced parenthesis at position 6. Now I could of course scan this entire error message, which is quite messy, and if I didn't already have a pretty good idea what's going on here, I probably would, but looking at the pattern I defined, right away I see a problem. It looks like I put this first parenthesis in between the backslash and the D instead of before backslash D. So let me change that. And now rerunning our code, sure enough, the format of both of our dates has been completely changed to our exact specifications. Now they're formatted year, month, day with hyphen separators instead of month, day, year with / separators. Pretty cool. Okay, so at this point, it feels like we're due, perhaps overdue, for you to tackle something on your own. Especially since we've now learned how to do so many genuinely useful things by combining regular expressions with Python. So up next, I've got a little mini project that will give you a chance to apply what we've learned about regexes so far and hopefully keep those neurons firing, so you'll be primed to tackle the final boss at the end of this section. I'll see you there. Welcome back. So now it's time for a little exercise / mini project. This section of the course is definitely on the longish side since there's so much material to cover, and I want to break it up a little bit with an opportunity for you to practice what you've learned on your own. So what kind of regexy fun do I have in store for you? Basically, I want you to write a Python function that anonymizes, there's that word again, or masks social security numbers. But, and this is the key part, only part of them, by replacing part of them with asterisks. So in case you're not familiar with social security numbers, the standard format is 3 digits, a hyphen, then 2 digits, another hyphen, and finally 4 more digits. So the goal of your function will be to take some text string as input and then replace any sequence of characters matching the format of a social security number with a string that replaces, or you could say masks, the first 5 digits of the SSN, but leaves the last 4 visible, as you see in the example on the slide here. There is an edge case, however, that may slightly complicate your approach. Your code should also account for instances where there's a sequence matching the first 2 parts of the social security number, basically 3 digits and 2 digits separated by a hyphen, but is not part of an entire social security number. If such a sequence is in the input string, your code should effectively ignore it, which is another way of saying your regular expression should not match it. Your regular expression, in other words, should only be matching a complete social security number. Finally, to test your function, you should use an input string that includes both at least one valid social security number and a sequence of characters that only align with the first 5 digits of the SSN, like we see here. So for example, after passing this text you see here into your function, the first 5 digits of the actual SSN should be masked, so to speak, by asterisks, while the other sequence of characters that looks like the first couple parts of an SSN, but isn't, should remain untouched. Okay, I think all that should be enough for you to go on, so I'll step aside and let you get to coding. Have fun, and I'll see you in my solution video up next. Okay, solution time. So I'm starting out already in PyCharm and having already created a Python file that I called SSN masker. Obviously, you can feel free to call the file whatever you want. And my first step here is, of course, going to be to just import our RE module. Next, since our goal is to define a function, I'll go ahead and do that. And I'll call my function mask SSNs. And that will just take one argument that I'll call text. Now, inside of this function, my first step will be to define our regex pattern. So I'll start simple and not worry about groups for now. I'll just define a pattern that should match any valid social security number. So I'll say regex equals, and I'll make this a raw string, and then I'll say \d for digit, and then a 3 inside of curly braces, indicating that we want 3 consecutive digits, and then a hyphen, then \d again, and then a 2 inside of those curly braces, then another hyphen, another \d, and finally a 4 inside of curly braces. So just this should be enough to match any social security numbers inside of that text input. But if you recall our goal here, we don't want to replace the entire social security number. Instead, we want to replace the first 2 components, but we actually want to keep those last 4 digits of the social security number. So the question, of course, becomes, how do we capture those last 4 digits so we can integrate them into our substitute string? Well, of course, that's as simple as just enclosing this last piece of our social security number pattern in parentheses to create a group. Then we can use back referencing to grab the actual value from that group and integrate it into our substitution string. Now, speaking of that substitution string, I'll now create another variable called clean SSNs to hold our cleaned up text with our freshly masked social security numbers. So I'll say clean SSNs equals, then I'll call that submethod on the RE module. And for our first argument, as always, I'll just pass in our regex pattern. Then for our second argument, I'll use a raw string. And the first part of this should just be a series of asterisks separated by hyphens. After all, we don't really need to know what those actual digits were from the social security number we're replacing, because regardless of what they were, we just want to see those asterisks. So I'll say 3 asterisks, then a hyphen, then 2 more asterisks, another hyphen, but now is where things get interesting. Now's where we want to grab the actual 4 digits from that last component of the SSN. And we can do that using back referencing by just saying \1 to point to the one and only group that we defined in our regex pattern. That being that last piece that we enclosed in parentheses. So now, with our substitution pattern defined, we'll just pass in our actual input text as the last argument to the sub method. Then finally, I'll just return clean SSNs from the mask SSNs function. Then, of course, down below, I'll want to test our new function with a test string. So I'll create a variable called sample text. And inside of that, I'll drop our sample text that will hopefully put our new function to the test. And as we see here, we have one example of a valid social security number and another that kind of looks like the first 2 parts of a social security number, but is not part of a complete SSN. So now down below our sample text, let's just print the result of calling our mask SSNs function, passing in sample text as the input. So now, running our code, drum roll please. Look at that. Those first 5 digits from our valid social security number were masked by asterisks just like we wanted, but that second sequence of characters, that looks like the first two parts of an SSN wasn't touched, since it didn't match the format of an SSN in its entirety. Not too shabby for a few lines of code, I'd say. Okay, so hopefully that one made you think at least a little bit, but wasn't too much of a hassle. So now, with your brain fully activated, let's dive back into learning more about regular expressions. See you in the next one. Hey, welcome back. So in this one, we're jumping back into the fray with another new concept: alternation in regular expressions. So alternation is a concept that allows us to match against multiple possible patterns within a single regular expression. In effect, it lets us say this or that when defining what we're looking for in a text string. The symbol we use to denote alternation in regular expressions is the pipe symbol, also known as the vertical bar. Okay, so let's start things off with the very basics of alternation in regular expressions. So when you place that pipe symbol I just mentioned between two patterns, it tells the regular expression engine to match either the pattern to the left of the pipe symbol or the pattern to the right. Let's look at a simple example. If we wanted to match either the string cat or the string dog in a larger piece of text, we could write the regular expression as cat, then the pipe symbol, then dog. In this regular expression, cat is the pattern to the left of the pipe, and dog is the pattern to the right. The regular expression engine will match either cat or dog wherever it finds them in the text. So if we had a sentence like, "The cat and the dog are friends," this regular expression would match the words cat and dog. To help this sink in, let's demo this example with live Python code in PyCharm. So back in PyCharm, I'll create a new file that I'll call Regex Alternation. Now first up, as per usual, I'll go ahead and import the RE module. Now, to start our example, I'll drop our example sentence, "The cat and the dog are friends," into a variable called text. So I'll say text equals, and there's our example string. Incidentally, I sure wish my cats and dogs were friends because it would make for a lot less drama around the house. Oh well. Okay, so next, we'll define our regular expression as a string in a variable called regex. And our regex will simply consist of the two patterns we want to match, cat and dog, separated by that pipe symbol. And as a result, our pattern should match instances of either cat or dog within the text string. So here I'll say cat, then that pipe symbol, then dog. So now we can use that Findall method from the RE module to search for all occurrences of our regular expression in the text and return those as a list. So now I'll declare a variable called matches. And into that, I'll drop the result of calling that Findall method from the RE module. And then, of course, I'll pass in our regex as the first argument and our text as the second. And then simply print the result. And now running our code. Just as we'd hoped, we get a list printed to the console containing the strings cat and dog. Okay, so now building on this example, let's explore how we can use alternation to match somewhat more complex patterns. So as you might expect, the pipe symbol isn't restricted to just plain text strings. We can actually use it with all the other components of regular expressions we've learned so far. consider this. We want to match a date string in the format month-day, where the month is either June or July, and day is a 1 or 2-digit number. We can achieve this by combining alternation with the special characters and quantifiers we've covered in previous videos. So let's go ahead and comment out everything we have here so far, except of course our line that imports the RE module. And now, rolling down our Python file a bit, let's construct the regular expression for our new example step by step. So I'll start, of course, by declaring a regex variable to hold our pattern. So I'll say regex equals. So to start building out that regex, we know for the purpose of our example, the month can be either June or July. So we'll start with June vertical bar July. Then for the day, which is a 1 or 2-digit number, we'll use the special character \d, which represents any digit, and then curly brace quantifiers to specify a minimum and maximum quantity. In this case, it will be 1, 2 inside of those curly braces, since the day can be 1 or 2 digits. So I'll say \d, and then 1, 2 inside of those curly braces. And then I'll, of course, put a space in between our months and the day of the month. But now, to complete our regex, I'll actually need to wrap our June-July piece in parentheses. And why is that? Well, those parentheses are used to group the months together as one unit. And this is necessary in this case, and in most cases, by the way, because if our regex doesn't set June or July apart as a unit, the regular expression engine would interpret this pattern as June or July followed by a 1 or 2-digit day, which is not what we want, obviously. Think of this a bit like using parentheses to enforce a specific order of operations in mathematical equations. And for the same reasons as in that scenario, I generally recommend wrapping your alternation logic in parentheses just to make sure it works like you expect. Now, speaking of which, when you incorporate this kind of alternation logic in the context of a larger regular expression, where there's more to it than just this or that, you'll want to enclose the entire regular expression in another pair of parentheses. This is especially true if you want to use the Findall method to return all matches in the test string based on your regex pattern. That's because if you incorporate groups into your regex pattern, as we are here, the Findall method simply returns the captured groups, not matches to the overall pattern. In other words, it just returns matches to whatever we have defined inside of those parentheses. So to be able to return matches that correspond to our overall regular expression, we should wrap the entire regular expression inside of parentheses. Then to complete our regex, I'll just turn it into a raw string by adding that R at the beginning. And now we're ready to define our test string, which I'll drop into a variable called text. And that test string is, I will be on vacation from June 28 through July 2. Sure hope so. Next, I'll again make use of the Findall method from the RE module to find all matches for our pattern in this test string. So I'll say re.findall and then pass in our regex and our test string. And then, of course, print the result. And now if we run our code, we see that we technically have 4 matches instead of 2. That's because this piece inside the inner parentheses that just consists of June or July technically is its own group. And we see that just that group matched June and July in our test string. But we also have matches for June 28 and July 2 that coincide with our overall regex pattern. Okay, so before we wrap up, let's look at another slightly more challenging, interesting example. So again, commenting on our code here, and then rolling down a bit further in our file. Now suppose we want to match a string that represents a date in either the format month-day-year or month/day/year. The month and day can be 1 or 2 digits, and the year should always be 4 digits. So with what we've learned so far, we should be able to construct the regular expression for this fairly easily. I'll start by declaring the variable as usual. So I'll say regex equals, and I'll make our string a raw string right from the get-go. Then I'll start with \d to indicate a digit, followed by curly braces with 1, 2 inside of those to indicate that we want 1 or 2 digits. That's for the month piece of our date. And now is where things get interesting. As the delimiter between the components of our date, we want to be able to match either a hyphen or a /. So we know that pattern needs to be hyphen, pipe symbol, /. And to make sure our logic works the way we want, we need to wrap all of that inside of parentheses. Next, we'll do the day, which will work exactly like our pattern for month, basically either 1 or 2 digits. And then another delimiter between day and year, which works just like our previous one, so I'll just copy and paste that. And then finally, \d, curly braces, 4 for the year. And finally, I'll wrap this whole thing inside of parentheses. Next, I'll define a variable to hold our test string, and then paste that right in. And as you can see, the idea is similar to our last example, except now we're matching a more generic date versus simply June or July. So now I'll enter down a few times and create a variable to hold our matches, then call that re.findall method, pass in our regex and our test string, and finally print the result. So now, running our code, looking at the output, you can see that everything that's enclosed in parentheses inside of our overall pattern got its own match because everything inside of those parentheses is considered its own group. However, the match to our overall pattern comes first. Now you may be wondering, how do we extract what we really care about here, which are the matches to our overall pattern? Well, the way to look at this is, our overall regex is a group in and of itself. You know that because we enclosed it in parentheses. Then, that overall pattern contains subgroups in which we defined our OR logic where we said match a hyphen or a /. But of those groups, the first group will always be the outer group, the group that corresponds with the overall regular expression. Now looking at our output, we see that it's a list, but that list contains 2 tuples, with each tuple containing not just a match, but all the components of that match. But crucially, the very first element of each of those tuples is going to be the match that corresponds with our overall regex pattern. So if we want to just extract the matches to the overall pattern and nothing else, instead of printing the matches variable as a whole, we can say matches 0 for our first tuple, and then access the first item inside of that, and then a comma, and then matches 1 for the second tuple, and then we'll access the first element inside of that. So now running our code again, now we get just the 2 dates from our test string that we were interested in. Now it's worth noting here that if you want to extract nested matches like these in a more scalable way, which would be necessary if we were dealing with more than a handful, you could use a loop or a list comprehension to iterate over the tuples inside the list and just target the first item in each one. Okay, so our long and winding road through regex land is nearly complete. But we've got one more stop ahead before we jump into the project for this section. So in the next video, we'll continue expanding our regular expression skill set by discussing another powerful tool, compilation flags, which can change the way regular expressions interpret patterns and drastically alter the way we work with them. See you then. Welcome back. So without a doubt, we've already built a strong foundation in regular expressions up to this point. But now it's time to explore one more feature of regexes that adds a new layer of flexibility: compilation flags. So what exactly are these compilation flags? Well, in the context of regular expressions, compilation flags are special instructions we can include to change how a pattern matches the text. Essentially, they let us modify the behavior of the pattern matching engine. So there are a few different compilation flags provided by Python's RE module, each with a specific purpose. We'll be exploring 3 of those in detail. First up is the ignore case flag, which makes the pattern case insensitive, so it will match text regardless of whether it's uppercase or lowercase. Then we have the multi-line flag, which changes the behavior of the start and end anchors, that's the caret character and the $sign character, so they match at the beginning and end of each line instead of at the beginning and end of the entire string. And then finally, we have the .all flag, which changes the behavior of the dot character to match any character, including a new line character, which it doesn't by default. Okay, so now that we have a brief understanding of what each of these flags does, let's dive deeper and learn how we can use them in our regular expressions. And we'll start by exploring the ignore case flag with a concrete example. So back in PyCharm, I'll create a new Python file called Regex Flags. And as usual, my first step will be to import that RE module. Next up, I'll define our test string, which I'll drop, as usual, into a variable called text. And that test string will simply be, Python is fun, but Pythons are scary. I think 99% of people would agree with at least one of those statements. But aside from that, note that our test string here includes the word Python twice, once in title case, with just the first letter capitalized, and once in all uppercase. Now, if we use that Findall method from the RE module to try to search for the word Python in this test string, and to do that, I'll just define a matches variable and then say re.findall, and then plug in Python as our search pattern, and then our test string. Now if I print that, and then run our code, we only get one match, the one where Python is in title case. But now let's see what happens when we use that ignore case flag as an optional third argument to the Findall method. So again, right after that second argument, I'll say re.ignore case. Note that I prefixed our flag with the name of the RE module. That's because, just like the Findall method or the search method, these flags are part of the RE module. So now let's run our code again, and look at that. When we pass re.ignore case as a third argument to the Findall method, it matches both Python in proper case and Python in uppercase. So as you can see, the ignore case flag, when passed to regex methods like Findall or search allows us to handle text that is not consistently cased or when the case isn't important for our pattern matching. Okay, so up next on the docket is the multi-line flag. So remember the anchors we discussed a few videos back? The caret character and the $ character, which match the start and end of a string, respectively? Well, by default, these anchors consider the entire text passed to any of our regex methods as a single string. But what if we wanted to treat each line as a separate string? Well, that's where this multi-line flag comes in. When we use the multi-line flag, those start and end anchors match at the beginning and end of each line, not just the beginning and end of the entire string. So let's see this in action applied to a multi-line string. So I'll go ahead and comment out everything but our line where we import the RE module, then roll down a bit in our file, and then create a new variable to hold our test string. But since this is going to be a multi-line string, I'll use a triple quote. Then for our multi-line string, I'll paste in the worst poem I can possibly imagine about the Python programming language. If, after reading this, your first instinct is to tell me to stick to my day job, you would be correct. But zooming in on the aspects of this string that are applicable to our discussion here, note that 2 lines of our example string start with the word Python. So our goal here will be to match any instances of the word Python at the beginning of a line, not just at the beginning of the overall string. First, let's at least try to do this the old-fashioned way with the Findall method and no additional flags besides the ignore case flag, which we know we'll need because Python is spelled in proper case in one instance and lowercase in the other. So we'll create a variable for this test string, and again, we'll just call it text. Then down below our text string, I'll create a variable called matches, and I'll set that equal to the result of calling our re.findall method. Then for our pattern, for the first character, I'll use that caret character that indicates we want to match the start of the string, and then just the text string Python. Then for our second argument, I'll just use our text variable. And then, since our 2 instances of the word Python are capitalized differently, I'll also pass in that ignore case flag as our third argument. Now I'll print that matches variable and then run our code. And we get no matches. Interesting. Even though we have 2 instances of the string Python in our test string, we went 0 for 2. So how did that happen? Well, as it currently stands, our regex is only going to match an instance of the word Python if it's at the very beginning of the string. And if you're a sharp-eyed observer, you may note that technically the first character in our string here is a new line character, since this first line of this poem technically begins on the second line of our multi-line string. In fact, if I were to hit delete right after our opening triple quotes to put that first line of our poem on the first line of our multi-line string, and then run our code again, now we get a match, but just for that first instance of the word Python. But again, we have 2 lines in our poem that begin with the word Python, and we're only getting 1 match. So at this point, it's probably obvious to you that we need to add another compilation flag, that being the multi-line flag. But what may not be so obvious is how to incorporate that multi-line flag as an argument to our Findall method when we're already passing in the ignore case flag. Now, the intuitive thing might be to simply add another comma and then tack that on as a 4th argument. But the way you actually incorporate multiple flags in a single regex method is with that same pipe symbol that we used for either or logic in the last video. So right after re.ignore case, I'll throw in that pipe symbol and then re dot multiline. And now if I run our code again, we went from 0 for 2 to 2 for 2. Even though this first line of our poem is technically on the second line of our test string, and even though our regex incorporates that start of string anchor, and neither instance of Python here is technically at the start of the string, we still match both of those instances because they do start at the beginning of their respective lines. All right, so moving on, let's dive into our third and final compilation flag for this video, the .all flag. So remember how the dot character matches any character except for a new line character? Well, that's its default behavior. But what if we want the dot character to match literally any character, including a new line? Well, that's where the .all compilation flag comes in. When that flag is used, the dot character will match all characters, including new lines. Let's see an example of this in action. So our goal here, using the same test string we used in the last example, will be to match a pattern consisting of the words light Python with literally anything separating those words. The appropriate regex for this, which at this point I figure you can probably come up with in your head on the spot, will simply be the word light, then a dot and a plus sign, indicating we want one or more characters of any kind, and finally the word Python. So if I comment out our 2 lines of code here, and then create a new matches variable below our test string, and again call re.findall, and this time I'll use that pattern that we just discussed, light, and then a dot, a plus sign, and Python, and then pass in our test string. And this time I'll just pass in the ignore case flag as our third argument. And then I'll print this, which makes me realize I did not need to comment out my print statement here. So I'll simply uncomment that out and then run our code. And we get no matches. But if we scroll up to analyze our test string a little more closely, we see something that should, at least in theory, match our regular expression, spanning the end of the second line and the beginning of the third line. Here we have the word light, and then a period, and then the word Python directly after that. But the problem here is the fact that our targeted sequence of characters spans 2 lines, and that line break is in between the 2 words that comprise the bulk of our regex pattern, means that the dot character separating the 2 pieces of a regular expression needs to be able to match a new line character, which again, by default, it does not. But of course, as you might have guessed, this is something we should be able to fix with yet another flag from the RE module. In this case, that being the .all flag. So we'll pass that in as a second compilation flag to our third argument. And now running our code again, now we get actually a bigger match than I had personally bargained for. I was expecting our regex to match this little sequence right here, spanning the end of the second line and the beginning of the third, but Python's regex engine, being both greedy to find the very first match it can get its hands on, and smarter than me, identified an earlier instance of the sequence of characters making up the word light, and since our regex literally says, match any sequence that begins with light, ends with Python, and has literally anything in between, this is the earliest and biggest match that the regular expression engine can identify. And note that inside that match, there are not 1, but 2 new line characters incorporated as part of that matched pattern. That's the power of the .all flag. All right, and with that, your training in regular expressions is complete. And that means you're ready to take on Bruno's project for this section. Coming up next, I'll have a video that introduces you to the project and walks you through all the requirements to complete it to Bruno's satisfaction. I'm sure your head is practically swimming with regular expression syntax at this point, so hopefully you're fired up to apply all that knowledge to a hands-on project. See you in the next video. Okay, so it's been a long section, but it's all been building up to the climax. Bruno's latest assignment for us. Now, this one's a little thornier than the last two projects, and it will definitely stretch your newfound regular expression skills, but if you work through it step by step, I have no doubt you'll get the job done. So for this project, we've been tasked with writing a Python script that does the following. It should open and read a plain text file, which is called exampleemail.txt, and I've provided this in the course resources. Then, your program should use regular expressions to extract any of the following types of contact information from the file: phone numbers, emails, or website addresses. Finally, it should write all those phone numbers, emails, and website addresses that it finds to their own respective text files. Now, to see what this looks like in a little more detail, looking at our example email here, we see that there are a number of phone numbers, emails, and website addresses scattered throughout, some in slightly different formats than others, just like real life. So the real challenge here will be to write regular expressions that can handle all of these different cases and then use those regular expressions to fetch all instances of those three kinds of contact info and then write them to their own respective text files. Taking phone numbers, for example, we see 1, 2, 3, 4, and 5 of them in this file. So when you run your script, it should create a file called phonenumbers.txt, or something similar, as you see here. And then when you open that file, you should see those phone numbers all listed on separate lines of the file. Note, however, that while there were 5 numbers in the example file, there were only 4 written to our new text file. But why? Well, switching back to our example file, we can see that those last 2 phone numbers are identical. So part of the logic in your script should keep duplicate phone numbers, emails, etc. from being written to a text file. Now, one piece of good news. Looking back at the project folder for this section, you can see that all the files for the project, the example email, the project script, and the 3 text files the project script creates, all live in this folder. Now, while you don't have to do things this way, it makes life a bit easier as opposed to having files in various different folders and needing to define explicit paths to target them. After all, the focus in this project is firmly on regular expressions, and I don't want other considerations to take up too much of your mental headspace. Now, speaking of regular expressions taking up your mental headspace, before I turn you loose on the project, I want to get a bit more specific on what your regular expressions should match. So for phone numbers, you should be targeting numbers that consist of 10 digits in groups of 3, 3, and then 4, in which those groups are separated by either hyphens or spaces. And you can see examples of all those scenarios here. Again, you have 3 digits, then either a hyphen or a space, 3 more digits, then another hyphen or a space, and then 4 digits. And then to make things even more interesting, we should also be able to match phone numbers in which those first 3 digits are wrapped inside of parentheses. Next up, we have emails, which should pretty much consist of a series of alphanumeric characters, basically letters or numbers, followed by an @ sign, followed by another series of alphanumeric characters, then a dot, and one of com, net, or org. So basically, we should be matching email domains that end in .com, .net, or .org. Now also, as you can see in the second example here, our email usernames should be able to contain dot characters as well, since it's fairly common for somebody's email username to be along the lines of first name dot last name @. Now also, since there are letters in these email addresses, we should tell the Python regex engine that we want it to match in a case-insensitive way. Now finally, for websites, it's pretty much the same deal as with the last section of email addresses. Pretty much everything in an email address after the username could also pass as a website. For example, hotmail.com, while a valid email domain, could also double as a website address, and vice versa. So the real trick here will be to find a way to identify that pattern, basically just a bunch of alphanumeric characters followed by .com, .net, or .org, but only if it's not part of an email address. Now I've got some hints on at least one way to go about this in the accompanying requirements document. More on that particular resource in a moment. Now keep in mind that when you're trying to parse patterns out of messy, real-world data, there are just about always more edge cases than you could possibly anticipate, and others that just aren't worth coding for if they're not a point of emphasis. For example, it's technically possible, albeit uncommon, for email usernames to have other characters besides numbers, letters, and dots in them. It's also not unheard of to see a phone number with no separators in between its sections, just a string of 10 digits. To say nothing of non-North American phone numbers, which can be structured quite differently than what we've seen here. I would just ask that you try to make your regular expressions at least comprehensive enough to handle the examples we just reviewed. But if you want to make them even more complex, good on you. I applaud your initiative. As a useful, practical example, if you want to make your phone number regex handle international phone numbers, go for it. Or if you want to include more types of email or website domains than just com, net, and org, have at it. I would just recommend, and this is whether you follow the instructions to the letter or even go above and beyond, that you make use of that Pythex website we used, or any easy and quick to use regex prototyping tool really, to test and play with the different components of your regex as you're building them out. Real-world regexes can get complex pretty quickly, and as with anything complex, breaking it down into smaller pieces as you work can help out a ton. Okay, so at this point I've given you the bare minimum info you need to start working on the project. So if you're feeling froggy, leap right into it. And when you're done, check out the solution video for a look at how I did it. If you'd like a little more guidance, however, I've provided a detailed requirements document in the course resources that contains lots of hints to help you get through the stickier parts. And there's also an optional starter file for the project with comments that can help you along as you work through it. And finally, if you're just still not comfortable with regexes at this point, you can always just skip to the solution video and follow along as you watch me code. Even if you opt for this route, however, I'd still recommend tackling the project on your own a bit later, just to get those reps in. All right, so with that, I'll step aside and let you start slinging regexes. Have fun, and I'll see you in the solution video up next. Welcome back. So let's jump right into the solution, shall we? As has always been the case throughout this section, I'll start by just importing our RE module. Then, as a first step in our actual script, and by far the hardest part, honestly, let's go ahead and create regular expressions for the three types of patterns we're trying to match, starting with a regular expression for phone numbers. So here I'll start by declaring a variable called phone regex, and then I'll create an initially empty raw string to populate that variable. So now to start building out that regular expression, we first need to consider that the first 3 digits of the phone number we're trying to match are optionally surrounded by parentheses. So how do we make those parentheses optional? Well, if you recall from earlier in this section, we can use the question mark special character to denote 1 or 0, i.e. optional, of the preceding character. So here we'll type an opening parenthesis followed by a question mark. But it's not quite that simple. Remember, parentheses are actually special characters in regular expressions as well, since we use them to create groups within our regular expressions. So I'll actually need to escape that opening parenthesis with a backslash. Okay, so that is our optional opening parenthesis. So next, we'll just define a pattern to capture those first 3 digits. And that's as simple as the \d special character standing in for any digit, followed by a pair of curly braces with a 3 inside. Then for that optional closing parenthesis, it's pretty much the same deal. We'll use a backslash to escape it, then the closing parenthesis, then a question mark to make it optional. Next up, we need to separate the first and second components of our phone number with either a space or a hyphen. Now remember, we can match any one of a series of characters in regular expressions by enclosing them within square brackets. So I'll type a pair of square brackets, and inside of those I'll just type a hyphen and then a space. Now the rest of this, thankfully, is pretty straightforward. We'll just do another \d, curly braces with a 3 inside of them for the next 3 digits of the phone number, and then another pair of brackets with a hyphen and a space inside of them for the separator between the second component and the third component, and finally \d, 2 curly braces, and a 4 inside of those for the last section of the phone number. And that's pretty much it for our phone regular expression. So now we'll move on to creating one for emails, which I'll call email regex. And again, I'll initially populate that with just an empty raw string. Now, as the first part of our email regular expression, we want a sequence of 1 or more alphanumeric characters, or a dot character, since many emails take the form firstname.lastname@failmail.com, then followed by the @ symbol. This is effectively the username portion of the email. In other words, picture john.doe @. So as a first step in building that out, let's try to match a series of 1 or more alphanumeric characters or dots. So because we know we're going to try to match one thing or another thing, we'll go ahead and use square brackets, just like in our last example. And inside of those, I'll use my special character for alphanumeric characters, which is just \w. And then I'll also throw in a dot, but keep in mind, a dot is a special character in regular expressions, so I'll need to escape that by preceding it with a backslash. Then, after our brackets, I'll throw in a plus sign, which makes sure that we'll match a series of 1 or more, either alphanumeric characters or dots. Finally, I'll follow all of this with that @ sign. Now next up, we have the domain piece of the email. What we're trying to match here is along the lines of hotmail.com, gmail.com, etc. Here, we again want a series of alphanumeric characters that are this time explicitly followed by a mandatory dot character. Hotmail dot, Gmail dot, etc. So that will look like \W and then a plus sign. So again, we're matching one or more alphanumeric characters, followed by \dot to explicitly match a dot character. Now finally, we want to ensure that the pattern ends with either com, net, or org. And we can do this using the pipe symbol inside of a group to apply that either or logic we saw earlier to these options. So after our dot here, I'll type a pair of parentheses, and then com, a pipe symbol, net, another pipe symbol, and then org. Then, since we're using a group in our regular expression here, in order to be able to extract our entire match with the Findall method, which only returns matches to groups if we use groups in our regex, we'll need to enclose the whole pattern in another set of parentheses. So I'll just wrap the whole shebang in one more pair of parentheses. And now we should be ready to move on to our website regex, which, as you've probably guessed, I'll drop into a variable called website regex. And I'll once again start with an empty raw string. Now, pattern-wise, a web address is effectively indistinguishable from the domain portion of an email. For example, hotmail.com and gmail.com are theoretically perfectly valid web addresses. And since it isn't terribly common for people to prefix web addresses with www. In the kind of free-form text document we'll be applying our regex to, we'll need a more sophisticated approach to distinguish website addresses from email domains, so our pattern doesn't just blindly match every email domain in our text file along with any web addresses. To do this, we can ensure that the first piece of our pattern is either the start of string anchor, our friend the caret character, or a white space character. The former indicates that the pattern occurred at the beginning of the string, meaning it couldn't possibly be preceded by that @ symbol that serves as a dead giveaway for the end of an email username. Now, the latter scenario, in which our pattern is preceded by a white space character, indicates that the pattern we're matching occurs after another separate word in our document, meaning it is again effectively the start of something new. And if our pattern truly starts with a series of alphanumeric characters, that means it can't be an email, which includes the very special charactery @ sign. Okay, so to that, we'll start with our either or choice between the start of string anchor and a white space character, using, of course, a pipe symbol inside of parentheses. So I'll enter those parens, and then our start of string anchor will go first, then a pipe symbol, and then the \s special character to stand in for any white space characters. Now after this, since, as we've discussed, a website looks just like an email domain, I'll literally just copy over the corresponding portion from our email regular expression. I mean, who doesn't love saving time on typing, right? So basically, everything after our @ sign here from our email regex, I'll go ahead and copy, and then paste right at the end of our website regex. Now there's one more twist we need to consider here though. While we need our pattern to include that start of string / white space character at the beginning, we don't actually want to include that in the text we capture from our regular expression and ultimately write to a text file. So what we'll need to do is capture the part of the regex we actually want to keep in another group by wrapping it in parentheses. So that part that we want to capture is basically the part that we just copied and pasted in from our email regex. So I'll just put parentheses around that. And at this point, our regexes should be good to go. So next up, we'll open our example file that contains all those emails, phone numbers, and websites that we're going to match. Now, we should remember mostly how to do this from a little bit earlier in the course, so I won't belabor the syntax too much. The main point is that we'll use Python's built-in read method, as opposed to the Readlines method, to read all the text from that file into a single giant string. That way, our regular expressions can scan that giant string, which they are more than capable of, rather than a bunch of individual lines. So here I'll say, using a with statement, with open, and then our example file is called example email.txt. And then, of course, we'll open that in read mode, and we'll alias that file object as simply file. And then we'll read that file with the read method on the file object, and we'll pass that in to a variable that I'll call content. Easy enough. Okay, so now we're ready to apply those regular expressions we created to the text string in this content variable using the Findall method. Then, for just the emails and the websites, which can include letters, we'll also throw in the ignore case flag just to make sure everything's case insensitive. So first we'll create a variable called phone matches. And into that, I'll drop the result of calling re.findall, to which I'll pass our phone regex, and then, of course, our text string in our content variable. Then I'll just copy and paste this and change phone matches on this line to email matches. And I'll change the regular expression I pass in to be our email regex. And finally, I'll make this one case insensitive by passing in the optional ignore case flag. Then I'll copy and paste this line and change email matches to website matches, and change my regex to website regex. And because, again, websites can also have upper and lowercase letters, I'll leave that ignore case flag intact. Okay, so this project is, admittedly, kind of a doozy, and we still have a little ways to go. So at this point, I'll give you a chance to take a little breather, and then we'll reconvene in part 2 up next. See you there. Welcome back. Now we're up against another interesting part of the project. It's time to actually grab the parts of these matches that the Findall method's producing that we really want so we can drop them into lists of our own. I'll start by doing that for the phone number matches. So scrolling down a bit, I'll create a list called phone list, which will be empty to start. So what I'll do now is loop through all the matches in our phone matches variable that were generated by the Findall method and write them to our new list, phone list. But because we'll ultimately be writing the contents of phone list to a plaintext file, and we want each match written to its own new line in the text file, we'll tack a new line character onto the end of each match before appending it to our list. So below our list declaration, I'll say for phone in phone matches. And then in here, I'll declare a variable called line. And this will just contain that individual item plus a new line character. So now, before writing the resulting text in the line variable to our list, let's test to see if it's already in our list. We can do this, of course, using the in keyword, or not in to be precise. So we'll say if line not in phone list, then we'll simply append it to phone list. So inside the body of the if statement, we'll say phone list dot append line. Okay, so now for the easier part of this equation, writing these matches we found to a new text file. Now there's nothing revolutionary going on here. Most notably, we'll make use of the Readlines method since we're writing a list of values to a text file rather than a single standalone value at a time. So outside of our loop, we'll say with open, and then we'll specify the name of our file, which will just be phone numbers.txt. And we'll, of course, open that in write mode. And we'll assign that to a variable called file. And then inside the body of our with statement, we'll simply call the Readlines method on that file object and pass in our phone list. All right, so that's pretty much it for the phone numbers. Now it's time to process our email matches. Now this is going to work almost exactly the same way as with the phone numbers. So much so that I'm just going to copy the code we just wrote here and change some of the details, or the deets as the kids say. So I'll highlight all of this, roll down a few lines, paste it in, and now I'll just change phone list to email list, phone here in our for loop to email, phone matches to email matches, and obviously I'll update any references to those variables as well. And then, of course, I'll write our results to a new file called emails.txt, and I'll write the contents of our email list variable to that. Now, wouldn't it be great if it were just this simple? But unfortunately, it just about never is. We have one additional wrinkle to deal with. Since our email regular expression, which we can see if we scroll up a bit, has groups, our target matches will be located inside of tuples that are in turn inside the list that contains the matches. Now we're trying to match the entire pattern in this case, so we'll want to grab the first item in each tuple. That means, scrolling back down, instead of just appending this email variable that we're grabbing throughout each iteration of our for loop that's going through the matches generated by the Findall method, I want to grab the first item inside of that variable, because what that variable actually represents is a tuple. Remember that when we use the Findall method with a regular expression that contains groups, it doesn't just produce a list of values, it produces a list of tuples. So here we're just grabbing the first item from each one of those tuples by saying email, then a pair of brackets, and a 0 inside, basically indexing inside of that tuple. Now finally, we'll again repeat almost the exact same steps to process website matches. So I'll again just copy and paste our email code this time and update the particulars. So let's copy this, roll down a few lines, and then paste it in. And once again, I'll just change all of these little references to email to website. And we'll write the results to a file called websites.txt. And of course, I'll be writing the contents of our website list variable to that file, not our email list. Now, just like before though, we're going to have to tweak how we target the text we're trying to get to within the list of matches produced by the Findall method. Rolling back up to look at our website regex, in this case, the text we want corresponds to the second group in the regex, which consists of basically everything after the initial group containing a start anchor or whitespace character. So as such, we'll need to plug a 1 inside of our square brackets here to target that corresponding second item in each of the nested tuples. Okay, so at this point, our program should be good to go. So when we run this code, here in our project folder, 3 new text files should appear, 1 each for phone numbers, emails, and websites. And those files should contain the corresponding matches from our example email file here. So without further ado, let's go ahead and run our code. Then, switching back to the project folder, sure enough, we see our 3 new files, emails.txt, phone numbers.txt, and websites.txt. But then the real test is, what is inside of these files? Do they actually contain the emails, phone numbers, and websites from our example email file? Well, let's go see. So let's open up phone numbers.txt. And here we see 4 phone numbers. And then if we switch over to our example email file, we see 1, 2, 3, 4, and 5 phone numbers. But if you look carefully at these last 2 phone numbers, they are identical. And if you recall, we baked logic into our solution so that duplicate values wouldn't be written to our lists. So this piece looks like a success. So now let's move on to validating our emails. So let's open up emails.txt. Looking promising so far. So if we again cross-reference that against our example email file, we see IT support at techfusion.com. We see john.doe at techfusion.com. We see finance at techfusion.com. And we see tcusack at aol.com. And sure enough, it looks like those are the 4 values in our emails text file. So finally, let's check out our websites matches. So opening that file, we have techfusion.com, techsupport.net, and pmguidelines.org. So cross-referencing that against our example email, scrolling up to the very beginning of our file, there's techfusion.com. Then later we see techsupport.net, and there's pmguidelines.org. So somehow, some way, in spite of the relative complexity of this program, we got it to work on the first shot. Not half bad, I'd say. All right, so I know the end of a project usually means we get to move on to a whole new section of the course. But before we do that, I want to take a quick detour into a method for optimizing the performance of our regular expressions in Python, the compile method. Don't worry though, it shouldn't take too long. I'll see you in the next video. Welcome back. So throughout our exploration of regular expressions in Python, we've been defining those regular expressions using raw strings. But now, before we move on to the next section, I want to show you an alternate method of defining regular expressions that offers some performance benefits over plain old raw strings. And that method is compiling those regular expressions using the RE module's compile method. So as the name implies, The compile method compiles a regular expression pattern into a regular expression object. This object stores the pattern and can then be used to perform match operations like match, search, and find all in the same way that we've been using simple raw strings up to this point. So why go to this extra trouble when our regular expressions have been working just fine for us up to this point? The answer is simple: performance. The compile method can enhance the performance, that is to say, speed, of our regexified Python scripts by pre-processing and optimizing regex patterns into executable objects. Now, using compile is especially beneficial when a particular regex is applied numerous times in a script, since this approach saves the Python interpreter from having to repeat the process of parsing the regular expression multiple times. This leads to faster execution. You can think of this as doing the heavy lifting just once and then reaping the benefits with each additional use. Obviously ideal for scripts that do a lot of pattern matching. But one thing I want to make clear is that while the compile method undoubtedly offers a certain level of improved performance for regular expressions in Python, its use is not a strict requirement for all regex tasks. The decision to use compile is best guided by context. If you're just writing a quick script to parse a single log file, for example, the performance gain from compiling your regular expressions might be negligible. In cases like this, the overhead of an additional step might not justify the minimal performance gains. As with so many things in programming, compile is a tool, not a rule. But with all of that said, to show you how compile works in action, I'll quickly refactor the script from the project solution we just walked through to use the compile method, instead of unadorned raw strings, to define the regular expressions within it. So as my first step, just to prove that there's nothing up my sleeve, I'll go ahead and delete the 3 text files that are the output of our project solution. So that would be emails.txt, phone numbers.txt, and websites.txt. So now, all I have to do to compile the regular expressions in our script is to feed those regular expressions to the compile method. So here I'll say re.compile, and then pass in that first regular expression, and then I'll just repeat that process for our other 2 regexes. Now, before we just charge ahead and execute this code, I want to show you something interesting that happens if we type a comma after the first argument of one of our compile methods. The IntelliSense in the PyCharm editor is telling us that the compile method actually takes a second argument, called flags, as in compilation flags. Now that means that down here, where we plug our regular expressions into their respective findall methods, we no longer need to specify the ignore case flags in those methods. Instead, we can move them right into the compile methods, where we're defining the regexes themselves. And that, of course, is true in general for other regular expression methods like search and other compilation flags as well. So now let's go ahead and move those compilation flags out of the findall methods and into our compile methods. And at this point, we should be good to test our refactored script. So let's go ahead and run that. And we don't get any errors. That's always a great start. But now let's check our project directory. And sure enough, we have our emails file, our phone numbers file, and our websites file back in the project directory. And if we take a sneak peek at the contents of those files, it looks like they're just the same as before. Now you might be noting that the performance benefit of this new approach wasn't exactly pronounced. Probably a matter of milliseconds if that. But that performance benefit could matter more if you're using the same regular expressions in many different places throughout your code. All right, so up next, it's a whole new section, and of course, a whole new challenge from Bruno. In this one, we'll learn all about how to automate that most indispensable of business software, spreadsheets, including both Excel and Google Sheets, using Python. See you then.
Nice work. You've just taken your first real step into the world of automation using Python. You learn how to write scripts that organize files, clean up messy text, and save yourself hours of manual work. Now's the time to take your skills to the next level by working on even more powerful automations, like working with spreadsheets, APIs, emails, and even AI-powered tools like OpenAI's API. You can start doing that right now by checking out Travis's full Python automation bootcamp, which is rated 4.7 out of 5, and it's been getting rave reviews. You'll also get access to our members-only Discord channel, where you can skip the line and get direct help from mentors and instructors. If this video helped you out, drop it a like and leave a comment, or just share with someone who's ready to stop doing repetitive tasks the hard way. Thanks for watching, and I'll see you inside the Zero to Mastery Academy.